Very good morning and very good afternoon. Welcome to this fifth IHR Young Professional Congress. My name is Philippe Gourbeville and I am the president of IHR. And it's a great pleasure for me to welcome you for this fifth Congress dedicated to the Young Professional Network. I would like, first of all, before to present few information about IHR, thanks the organizing committee and especially my two colleagues, David and Michael, who will present few information about the Congress in a minute, and obviously the people from the Secretariat in IHR who have been behind the scene playing and organizing the things. As you saw through the small video that was played just a moment ago, IHR is an organization which is established since a long time. Let me try to play this. Yes. Yes, few slides regarding what IHR is. Just to remind that we are a scientific organization which is gathering more than 5,000 individual members, gathering also institute members and obviously young professionals. We are existing since 1935, just by the willingness of international labs to try to work together to improve standards in the hydro sciences in a global way. We are represented in all the continents around the world. More than countries are joining us and participating to our activities over the 85 past years. We are covering the full spectrum of the water sectors. You have seen on the small clips that we have working groups, technical committees. In fact, we are addressing most of the key challenges in the water sectors. For our new strategic plan covering the period of 24 to 27 over the next 4 years, we have the ambition to become a global hub of knowledge and innovation for holistic water engineering. Engineering is the DNA of IHR, and we would like to focus our activities, our efforts for providing solutions for climate change adaptation and mitigation, for water, for energy transition, food security, and nature-based solution, but also addressing how to improve resilience against water hazards and disasters. We have also a cross-cutting topic which is related to digital transformation, which is strongly affecting the water sectors and all the different type of professional profile. The activity of IHR is to bring a global vision of the reality and to accelerate collaboration with National Water Association. In this direction, we have expanded our activity to try to attract more professionals and practitioners to be interested in our activities, because we are providing solutions that could address all the challenges all around the world, and we need to spread very widely our solutions to the practitioners and to the operational field. What you have on the slide is some of the recent activities we have created and initiated with different countries over the past months around the world. IHR is, of course, science and techniques, but it's also education. And we are very pleased to have launched since this year the IHR UNESCO joint label for water training and education. As you are a young professional, you may be still interested to know more about this label, which is awarded to institutions that are providing quality and excellent education in the water sectors. We are also part of the activity related to the climate. We are strongly related to the United Nations organization, and we provide inputs to the major events that are taking place and that are related to water. We are also interested in the professional sectors, and we are now one of the liaison organizations for the International Organization for Standardization, which is a key actors for engineering solutions that are developed. Of course, and you know that very well, we are also a publisher. We have many activities that we are presenting through publications that could be the Hydrolink magazine that we are offering freely, but also journals, papers, and different books that we are publishing and contributing to spread around to the community. And one of the most important part of our activity is dedicated to the young professional, and this Congress is especially for them. We have those 56 young professional networks all around the world where we are attracting and networking young professionals involved in the water sectors. This activity is growing, and we are more than happy to welcome more than 800 participants for this current event. And this is just a demonstration that having virtual Congress is also a way to connect and to enlarge activity in our association. So this Congress will last for 3 days. It will start today and will continue up to Friday in order to allow more participants around the world to follow the different presentation. To conclude, I would like also to remind you that in addition to the virtual seminars that we are offering, we also organize face-to-face activities. We will have very soon our World Congress taking place in Singapore, and I would like to invite you to consider your possibility to participate and to join the Singapore event. This is still possible. The call for papers is still open. You can still also join some special session that will be open. With that, I would like just to stop my presentation and remind you that participating to the event in Singapore will be the opportunity to meet also your colleagues, your friends, to exchange with some representatives from different countries, and also to enjoy a fantastic country, a fantastic Congress, where you may have discovering new possibilities for your professional careers, and also to discover more important friends for the rest of your life. So with that, I will just give the floor to Elsa to play the video for Singapore. And I would like to wish you a very successful participation to the 5th IAHR Young Professional Congress. Thank you very much.
Well,
Hello, good morning, good afternoon, everyone. My name is David Ferras, senior researcher at the University Polytechnic of Cartagena, Spain. And together with Michael Nons, I have the pleasure to chair the EPD committee. And I would like to say some few words now about this committee. So now I'm sharing my screen. Michael, if you cannot see my screen, please let me know. EPD stands for Education and Professional Development. So the main goal of this committee is to promote education and professional development throughout IHR community and at both levels, regional and worldwide. And these are the 10 leading team members, very active IHR members. So the EPD committee organizes a number of activities for young professionals. These are some examples from this year activities 2024 and what we have in the pipeline for 2025. So during 2024, at the beginning of the year, we organized the 4th IHR Young Professionals Hydro Environment Challenge. And right now we are starting the 5th Young Professionals Online Congress. And in the pipeline, in our calendar, we also have for 2025, especially in the framework of the IHR World Congress in Singapore, a mentoring program, the most active Young Professional Networks Hour, and the JFK Student Paper Competition. So let me say some few words about these activities, starting by the JFK Student Paper Competition, which is an award that acknowledges the most outstanding student papers in the framework of the IHR World Congress. And who can apply? I invite you to have a look at the IHR website where you will find the bylaws. They are easy to find. And there is a detailed description about eligibility criteria, the detailed process on how to apply and proceed with this competition. Basically, if you are a student, no matter if you are an MSc, PhD student, no matter if you are young or not so young student, there is no age limit. You can apply for the competition when submitting your conference paper. You just indicate that you want to run for the JFK student paper competition, and then your conference paper will be evaluated by the JFK jury. If you are shortlisted, then you will be invited to participate in a special session devoted to the award. And these are some the names of last edition winners. And I'm happy to see that these researchers, they have been also involved as keynotes in this Congress. So hopefully you will get to know them better during the following days. Then the EPD committee also organizes, is taking care of the YPN Award, the Young Professionals Network Award. If you are involved in a young professionals network, or if you are especially if you are in the leading team, you will eventually be aware that once in a year, you are asked to submit an annual report of activities. So the APD will evaluate this annual report of activities and come up with a ranking of the most active young professional networks. And this is the example of last edition winners. There is an award per every region. So Europe, Asia Pacific, Latin America, and Africa. I would like also to mention the mentoring program, which is also an EPD activity organized during the IHR World Congress. So basically, whoever wants to participate, the participants, they are classified between mentors and mentees. Then there is some matching. And mentors and mentees, they are invited to have up to three meetings. One before the Congress, an online meeting, of course, where the goal is to break the ice, to get to know each other, and maybe discuss how you will meet face-to-face during the World Congress in Singapore. This is the second meeting. So the face-to-face in which the main goal is to discuss about professional concerns and also concerns about IHR association in general, even technical concerns, if so, even though this is not the main criteria when matching mentors and mentees. And then a third meeting, an online meeting in this case, after the Congress as a follow-up. So if you think this is appealing, do not hesitate and register for it. Registration, I believe, is not yet open, but it will be soon open. So please stay tuned. I would like to finish this talk giving three little pieces of advice. The first advice comes from the book 100 Years of Solitude from Gabriel García Márquez, where there is this special character, Colonel Buendia, who is a kind of artist. And he used to create teeny golden fishes, crafted golden fishes, out from golden coins. So he used to melt the coins in order to produce, to craft these golden fishes. And then he will use the crafted golden fishes to sell them and get more coins to again melt these coins and produce more golden fishes. This way, iteratively and endlessly. This example makes us think that eventually there are two types of people, no? The ones that they like to make money, but also the ones that they like to use money eventually for a better purpose. I believe academics were this kind, no? Because we use some financial resources to produce some knowledge. The second piece of advice comes from David Foster, who during a graduation speech, he provided this tale from about two junior fishes, which are swimming downstream a river. And then while they are swimming, they meet a senior fish who's swimming upstream. And then the senior fish will tell them, good morning, boys. How is the water today? Then the junior fishes will say, good, good, they will continue. And after a while, one junior fish will tell to the other junior fish, what the hell is water? So this tale makes us think that it's very important to understand, to get to know, metaphorically, of course, the waters we are swimming. And this is a skill very important for a good professional. No? And many times it's what distinguishes between junior and senior professionals. And yeah, the last example comes from a philosopher, from Imre Lakatos, from the book The Methodology of Scientific Research Programs. This is not a tale, it's a reflection. And he stated that a scientist tends to understand little more about science than a fish about hydrodynamics. So this makes us think how important it is to reflect about the work we do as researchers and also to reflect about science itself. No? So this has to do with philosophy of science. And this will make us better researchers. So notice that these three pieces of advice, the first one has to do with becoming maybe a better person and academic. The second about a better professional. And the last one about better researcher, scientist. Well, it's a coincidence, no? But these three examples, fishes are related, no? So a funny and friendly face to finish this talk. Thank you very much. I hope you enjoy the following Congress days. And thank you, Michael. Back to you. Thanks.
Thank you very much, Travi, for the introduction. Yeah, I'm Michael Nones. I'm the chair of this fifth edition, and I will present some information on behalf of the entire organizing committee. So, as already anticipated in the introduction, we are on the fifth edition, which means that is the fifth year in a row that we are running this Congress. We started in 2020 because of the COVID situation. And as APD, we consider important to have an online opportunity to meet and also to reach people not usually reachable through in-person events. And we started this journey, which is still continuing thanks to the involvement of multiple people, authors and first, but also organizing committee, secretariat, and IAHR in the background. As said by Philip in the introduction, IAHR is composed by a number of people, but the most important part is young professionals. It's you, which are combined in more than 50 YPNs, spanning more or less the entire globe. And this can allow you to interact, to network, to collaborate between each other, to leverage any IAHR events, to get trained and to get mentored, and also to interact with more senior members. And also this online Congress, it's about this, because it's not only about presenting the process, but it's also to discuss with the chairs during the coffee breaks. So the idea of the Congress, as said, is to presenting your work through posters, a quick presentation, then to get mentored and to discuss with peers about your research to eventually figure it out, what's the next step and how do you prefer to see the future. Then, of course, you can make your work known and have it available in the IAHR library to the proceeding, which will be edited just after the Congress. And some other works will be selected to be published in different journals of IAHR. Some numbers about the Congress, where we are. We already say that we have more than 800 participants, and we received more than 140 abstracts with number of authors. And all those abstracts came from all around the world, covering all the entire regions, and covering also all the IAHR teams. As David anticipated, we will have 2 keynote lectures given by young professionals. And we have also, of course, the involvement of multiple persons. The organizing committee is composed by 9 members that you will get to know during the Congress. And we have also more than 70 experienced researchers that provided their input for revising your abstracts. We acknowledge the support of 4 different organizations, and we also acknowledge the support given by Bechtel as a main sponsor of the Congress. So quick overview how this Congress will look like. We have 3 days. 2 days after the opening, we will start with the climate change adaptation sessions. to then go to the coastal and maritime hydraulics and the groundwater hydraulics at the end. All those technical sessions will be followed by a half an hour of discussion, of coffee breaks with mentors. So I really encourage you to stay connected and ask as many questions as possible to get mentor and to interact with all the presenters and the chairs. For tomorrow, we start at 10 a.m. European time with the fluvial hydraulics and ecohydraulics session. Then we move to fluvial mechanics and ice research and engineering. And then we will have 1 hour of keynote lecture given by Mina, who won the JFK last edition. And then in the afternoon, we move to the experimental method instrumentation session. And the last one will be urban drainage. On the last day, we start with the keynote lecture, in this case given by Marco, who was also an awardee of the JFK of the last edition. And then we will move to hydrodynamics and global water security and flood risk management sessions, while in the afternoon, it will be the last couple sessions on water resources management. So by saying that, I finished my introduction, and I would like to pass the video to Elsa to share a short video from the main sponsor, Bechtel, and then give the floor to Isabella Ravina for the first session on climate change adaptation. Thank you very much.
carrying sea level 100 miles up to the site. In a mobile launcher for NASA to send astronauts to the moon and eventually Mars. We go where no others have been. We do what no others can do. We do what can't be done. We are Bechtel. We are Bechtel.
We are Bechtel. Nosotros somos Bechtel.
Somos Bechtel.
These Bechteles.
We
We
are Bechtel. We are Bechtel.
In a couple of minutes, we're going to start with the first session. And I would like to ask all participants of this session to put up your hand, your virtual hand, so that we can upgrade you to panelists. Thank you. So welcome everyone to this first session of this Young Professionals Congress. This session is on climate change, and I would like to welcome my co-host of this session, who's together with me. We're from the organizing committee, and we're gonna look after the technical side of this session, Jose Carrillo. And I would really like to welcome the mentors of this session, Isabella Schalko and Ravinta Vital Kale. So please take over chairs of the sessions. Thank you. And you're muted. Please open your microphone.
Okay, sorry. Good morning, good afternoon, Eva, and all the members. I welcome my chair, Isabella, and both the hosts and all the presentation in this session on climate change adaptation. And we have 10 presentation here in this session. And we have time of 1 hour and 30 minutes. So in 1 hour, we have to complete our presentations. So each presentation will get 5-minute times. Before starting presentations, I will give one information to you as mentioned, because I am acting as a member of IAHR Technical Committee on Flood Risk Management. So I will briefly give brief background. Flood Risk Management Committee is a key topic of current concern for the water community, driven primarily by transformation of rural landscapes, sustainable urban population growth, and climate change. At the same time, IHR needs to be more focused on problem solving in practice, and other committee such as fuel handlings and fuel mechanics are narrowly focused on handling processes. Following discussion within IHR and other organizations like IHS, IWRA, the IHR Council approved at 2015 meeting the establishment of new technical committee on flood risk management, which held a launch meeting during 2015 IHR World Congress in The Hague. Mainly in this committee, research agenda is to prevent, protect, preparedness, and emergency response to flood risk management. With this brief discussion, now I want to call want to start a presentation in this group. So I want to call presentation one by one. First, I would like to call presenter Quentin Fiacre Togbevi. Sorry, there is a problem in pronunciation. He is going to present on hydroclimatic modeling of a tropical West African catchment under climate change. So please, Quentin, please start your presentations. And you try to finish your presentation within 5 minutes. Then we will take question answer for 1 minute.
Okay, thank you very much. Hi, everyone. My name is Quentin Togbevi from Benin. So my presentation today is about hydroclimatic modeling of a tropical West African catchment under climate change. The objective of this work is to assess climate change impacts on water resources in Tele catchment. Tele catchment is located northwest of Benin in West Africa and cover an area of 828 square kilometers. So to achieve this objective, apart from the catchment-based data, observed and simulated data were used. Observed data were obtained from the Met Service in Benin, and then the simulated data were retrieved from Codes Africa archives. For that purpose, 4 regional climate models under 2 climate scenarios, CP 4.5 and 8.5 were considered. Then the bias-corrected regional climate model were used as inputs in already calibrated and validated soil and water assessment tool models for climate impact assessment. Result of this work indicated that climate ensemble model, the climate ensemble model depicted a decrease in precipitation, annual mean precipitation, about 1.7% regarding RCP 4.5 and 4.1% regarding RCP 8.5. For the surface runoff, the climate ensemble model show an increase of about 4.3% under RCP 4.5 and 13.9% under RCP 8.5. Concerning the groundwater, the climate ensemble model also indicated a general decrease of about 30% under RCP 4.5 and 21% under RCP 8.5. And then Regarding the discharge of the catchment, the climate answer model indicated also an increase of about 29% under RCP 4.5 and the general decrease of about 59% under RCP 8.5. So based on this finding, it is recommended to policymakers to enable water resource infrastructure, such as reservoir, to avert water shortage or excess in the Tele catchment. Thank you very much.
Thank you very much. If any question, can we take one or two questions? If there is no question, we will move to next presentations. Next presentation will be by UZ Chai on assessing the potential sensitivity of Typhoon Nesat to climate change under SSP 5 and 8.5 scenario. Please, UZ Chai. Hello.
I think the presenter is not here. Should we just move
hello
to
everyone. Can you hear me?
Perfect. Perfect.
Sorry for the late to start my computer.
No problem.
Okay, so let me start today's presentation. So I'm Yujie Chai, a PhD candidate from the University of Ottawa. The study at present day is to assess the potential sensitivity of Typhoon Nesat to climate change on the SSP 5 8.5 scenario. So far, understanding how climate change influences typhoons is becoming a very hot topic. But the knowledge of how different climate variables will affect typhoons remain limited, especially for the Philippines, which is one of the most vulnerable regions around the world to such events. So to bridge this kind of gap, this study takes Typhoon Nesat as case study using pseudo-global warming method with WRF model under SSP 5 8.5 scenario by 2100 to project how typhoons will change in the future under climate change and which kind of climate variable plays a dominant impact on future typhoons conditions. Here, the 4 pseudo-global warming cases were established based on the changes in different climate factors between future conditions and the present conditions, including sea surface temperature, air temperature, relative humidity, and geopotential height and wind velocity. The results show that the Typhoon Nesat will be more intense in the future by 2100 with stronger wind speed and minimum sea level pressure as shown in figure 1. In here, the warming sea surface temperature is a dominant factor, results in the future stronger typhoon. But the warming air temperature will suppress this kind of typhoon's intensification. Additionally, changes in relative humidity, geopotential height, and wind velocity lead to just slight increases in the future of the typhoon's intensification. From figure 2, we can see that the overall trend of all future projected tracks remains similar to the present conditions. Those results are mainly due to the contribution of heat release from ocean to the development of typhoons. So in conclusion, they started to Typhoon Nissan actually started to conduct the first assessment of the typhoon response to global warming conditions under the worst condition. Under the worst future condition, SSP5 8.5 scenario by 2100 using the latest version of climate models in the Philippines. It indicated an intensification of future typhoons. And in here, the warming sea surface temperature, this kind of climate variable plays a dominant impact to cause the future stronger typhoon. So the funding from this study can provide some supportive information for the local disaster planning and mitigation efforts, also in the vulnerable regions. So that's all my presentation on my this project. Thank you very much.
Can I start?
Yes, please go ahead and start. So I think that, yeah, there was a problem with being muted. So the next poster is on climate change impact on catchment discharge using an ensemble of climate simulations. So Quentin, please go ahead and give your presentation.
Okay, thank you very much. So good morning once again. My name is Quentin Tagbevi from Benin. So my second presentation is about climate change impacts on climate discharge using an ensemble of climate simulation. The objective of this work is to assess the impact of climate change on discharge in Uri-Yori catchment. The catchment is located in northern parts of Benin in West Africa. So to achieve this objective, both observed climate and simulated data were retrieved. The observed climate data were obtained from the Met Service in Benin, and the simulated climate data from CODES Africa Archives. 5 regional climate models were used under 2 main scenarios, RCP 4.5 and 8.5. The bias-corrected regional climate model data were used as inputs alongside with the catchment-based data in the already calibrated and validated soil and water assessment tool models for the climate impact assessment. So the result of this study indicated that climate model ensemble show a decrease in precipitation under RCP 4.5 of about 44%, and a mixed trend in precipitation under the second scenarios, RCP 8.5. Regarding the runoff, the surface runoff, all climate models except the MPI RCA indicated an increase in surface runoff up to 114% under RCP 4.5, and a decrease in surface runoff up to 83% under RCP 8.5. Also, the climate model ensemble indicated a general increase in discharge of about 29% under RCP 4.5, and a decrease in discharge of about 59% under RCP 8.5. So based on this finding, we recommended that adaptive strategies are needed to cope with both projected increase and decrease in discharge that could potentially lead to water shortage or floods in the catchment. So this is all for my presentation. Thank you very much.
Thank you very much. Is there any question from audiences on this presentation? I think there is no question. Then we will move to next presentation. Next presentation is on effect of landslide disaster on the sediment transport of the Chicago River using the 1D sediment transport model by PU, PAN-EI. So I want to call PAN to present his study.
Can you hear me?
Oh.
Okay, then I will start. Hello, everyone. Good evening in Japan. So my name is Bai Pyu from Tokyo Metropolitan University. Today I would like to present a part of my research. Title is Effects of Landslide Disaster on Sediment Transport of the Chicago River using 1D sediment transport model. So Chicago River is a small river compared to other continental river, which is located in southwestern part of Japan. It has a total length of 143 kilometer and watershed area of around 3,000 square kilometer. And the table 1 shows the basic information of this river. Since, as I mentioned, it is smaller compared to other continental river, but some of the characteristics are same as the large river. For example, it has a macro-tidal estuary, which has a tidal range of from 1.5 to 5 meter. So in recently, Chicago River Basin, landslide disaster and flooding triggered by heavy rainfall events increased. So therefore, the objective of this study is to analyze the river morphology changes and sediment transport of this river triggered by landslide disaster. So to understand the effects of disaster, we have two study period. That is, first is no disaster period from 1998 to 2007. And second is disaster period when disaster occurrence or disaster increase from 2011 to 2020. And we apply Hagrid's 1D transport model, which is a famous open source model to get to understand the river morphology changes and sediment transport changes. Before we add the sediments into the model, we perform a steady flow models to confirm many reference and the river cross-section interval. So the finalized calibration is done with by changing many reference value, and the finalized value is 0.035 for the upstream part, and middle part 0.0325, and for the estuary 0.03. So after performing a steady flow model, we start to reproduce the no disaster period 1998 to 2007, and validation was done through river sediment volume changes compared with the survey data. And after model 1, we use the result of river topography, river geometry output on model 1 as the input of model 2. So as shown in figure 2 and table 2, the model could reproduce the elevation changes and sediment volume changes well, except for the estuarine part. As I mentioned, this is because of the tidal sediment transport. Because in Chicago estuary is a macro-tidal estuary. So there is a tidal sediment transport, but in the model, we don't have sediment transport from the downstream direction. So except estuary, the model could reproduce both sediment volume and elevation changes. Since it can reproduce riverbed elevation changes and sediment volume changes, we could discuss the sediment load changes between these two periods. So sediment loads of 3 different stations at 62 kilometer, 50 kilometer, and 40 kilometer station were extracted for P1 and for period 1, no disaster period, and period 2, disaster period. As you can see, for the 40 kilometer in figure 3A, 40 kilometer and 62 kilometer, there were no significant changes between the coefficient of rating curve parameters. However, for the 50 kilometer, there is a significant increase in both coefficient A and coefficient B. For the coefficient A from 0.0155 to 0.215. For the coefficient B, 1.415 in no disaster period and 1.523 in disaster period. So this increase in parameter coincide with the occurrence of landslide disaster, which happened between 50 to 60 kilometer of the right bank of the Chikugo River in 2017. According to the government report, about 2.1 million meter cube sediments were expected to flow into the Chikugo River from the disaster area to the Chikugo River. So in the survey data, about 1.73 meter cube or sediment volume increase between 23 to 63 kilometer. So we conclude that the increase in sediment volume and the increase in rating curve parameter during period 2 that is related to the sediment landslide disaster happened in 2017. That's all of my presentation. Thank you very much for your attention.
Ravindra, you're muted. We can't hear you.
Sorry. Thank you, Ben, for your nice presentation. I have one question because
Yes.
you have used one-dimensional HECRAS model for
Yes.
sediment assessment.
Yes.
So my question: how you collected data required, sediment data required for this modeling purpose? I mean for calibration and validation of HECRAS model.
First of all, we perform unstudy flow, as I mentioned in the presentation. For unstudy flow, it's like a case study, like for the we perform unstudy flow for the 2017, 2018, not all the year because this is long-term study. 2017, I remember for the low flow data, I performed 2006 for the high flow flooding year, 2017 to 2020. We have the 1 hour interval water level data and discharge data for around 4 stations. So we could calibrate and validate easily. And after that, we perform quasi and study sediment transport. So for the sediment input, we use rating curve equation. So first we reproduce the model 1. Model 1 is no disaster period. For the initial riverbed, we have 1998 topography, 200 meter interval survey data. So that is the input geometry file of our data. And we have rating curve. Rating curve is we change the rating curve because we want to reproduce the riverbed. So we change the rating curve and check the riverbed, and also validation is with the survey sediment volume calculated from the 200 meter survey data. So in this way, we perform model 1 first, and then we get the output of the model 1, and with output geometry as the input geometry file of model 2. And same procedure, we perform model 2. And then we could discuss how rating curve parameter change at different stations, spatial and temporal changes. I think this is the it might be is it okay for your answer?
Yeah.
Okay, thank you very much for your question.
Thank you. Is there another question from any audience? If not, then I want to call my chair, Isabella, to moderate next.
Oh yes, I am reading.
Hello.
Yeah. So the next speaker is going to be Martik Sivatasan Jigatan. I'm sorry for the pronunciation. And the title is Enhanced LULC Mapping Tool for Change Detection and Temporal Analysis. So the floor is yours for the next 5 minutes for the presentation.
So I'm Sanjay from IIT Kharagpur of India. So today my research is titled Enhanced LULC Mapping Tool for Change Detection and Temporal Analysis. So we all know that the land use and land cover change, the temporal change obviously affects the hydrological cycle, influencing the water demand and the supply cycle. So there is a need for the LULC map generation at an easier and at a simple level for the researchers to analyze and understand the changes and take informed decisions. So in this present study, an already Jupyter-based Python LULC mapping tool developed by Chen et al. 2023 was enhanced in the study by incorporating the temporal analysis and the change dynamics of the land use through a chord diagram. So the figure 1 shows the chord diagram wherein chord diagram shows the transition of land use classes over the years. For example, this is an example. This is the land use transitions from 2090 to 2023 of the Kansabati River Basin study area present in India. So all the different chords are different land use classes, and that the chord moving from one to another, from one node to another, is the transition from the 2019 to 2023. For example, the orange chord represents the crops, which has moved towards the red node, which is the trees. So it is understood that the crops has been converted to trees or somewhat. And so this is generally the chord diagram, which is not much used in the land use analysis studies, but here it has been incorporated to easily analyze the transitions of the classes and the magnitude of the transition over a different time periods. So the mapping tool is based on LULC and uses machine learning algorithms such as random forest and CART, classification regression tree. And but here I've used a random forest algorithm which produced a classification accuracy of 0.74 when trained with the Landsat images with 1,000 samples derived from the dynamic world land cover dataset. So here we as researchers, we stop at the 0.74 and tell that this land use data is good and we start using this. But upon close looking on the chord diagram and the confusion matrix produced by it, you can see that the built-up area has been actually converted to cropland over the period of 4 years, which is like realistically it cannot be possible. So also you can see that from the confusion matrix, the values of cropland to cropland and the tree to tree are 0.7 and 0.9, which is higher value. So it indicates that the cropland and the tree cover are getting predicted more accurately compared to other classes. In the case of the built-up area, the built-up area is getting predicted as either trees or crops, as given in the confusion matrix by their values 0.22 and 0.3. So essentially, the 0.74 is the classification accuracy of the model, which is comparatively good to be used. But realistically, when looking closely through the chord diagram and the confusion matrix, it seems that it cannot be realistically much. So the chord diagram, essentially what it does, it magnifies the remaining 24% of error, the error in the misclassification. It magnifies the misclassification being done. So this study, which was aimed at enhancing the LULC tool to incorporate the chord diagram, also magnified the misclassification being done. So which can be further improved by addition of post-classification algorithms like other than this, and addition of transformer algorithms also. So this should be the methodology should be fine-tuned, and the way of seeing the land use classification algorithm should be modified a little bit. Apart from it, the tool was also enhanced by addition of input of option for adding shape files and option for downloading the LULC map, and also other line plots and SAP files was generated for the tool. So this is my presentation. Thank you.
Yeah, thank you very much for the presentation. If there are any questions, please write them in the Q&A and we will collect them. And then we have something to discuss during the coffee chat. So please, if you also have questions from the talks before, feel free to just add them to the Q&A and just really ask any question. I'm sure the presenters are more than happy to answer them. And so now we come to the next talk by Elias Dado, and the topic is spatiotemporal rainfall variability and trends in Wolaita Zone, South Ethiopia, creating interpolation and innovative trend analysis approach. So please go ahead with your talk.
Okay. Good morning and good afternoon, please. I'm happy to present my findings titled Spatio-Temporal Rainfall Variability and Trends in Wolaita Zone, South Ethiopia, through the carrying interpolations and innovative trend analysis approach. As we know, climate variability is critically affect the developing country like Ethiopia, particularly agricultural and water resource. Rainfall trends are vital for the planning and sustainability. So the objective of these findings was to investigate the rainfall variability from 1987 up to 2021 in Wolaita zones using spatial temporal analysis by using the software like ArcGIS and Excel status and other program, and through the technique carrying interpolations, mind candle tests, and the innovative trend approach. Particularly, the Wolaita zone is situated in the southern part of Ethiopia with the diverse topography from the highland 2,900 meters up to the lowland 350 meters, and also they have various climatic zones like the Kola or lowland 35% and midland 56%, and also highland 9%. And in the meta sections, the data was used from the National Meteorological Agency. Station-based data was used, and also to fill the missed data, I used the Markov chain Monte Carlo techniques, and also the quality assurance and advanced technique was used to fill this missed data. And in analysis technique, weighted rainfall estimations and also cringing for spatial interpolations was used to assess the variability and the statistical index like correlation coefficient, CV, precipitation concentration index, and seasonal or standard anomaly index were used. Here is the key finding also: rainfall distributions. Rainfall distribute in annually from 969 up to 1,648 millimeter from lowland to highlands, and there is the seasonal contributions like the current 40.45% and Belg 38.13% and Vega 21.42%. They contribute, and the variability for the current, that means the summer, high variability were conducted, or high variability has been seen, like the CV of 30.15, and also there is in Vega very high variability. That means the CV of 37.57 was evaluated, and also to trend annual and in current season there is a declining trend is in Vega, rainfall also in increasing slightly. So that innovative trend analysis, there is a low to high value is increasing and a medium value of declining, and in seasonal trend change in rainfall extreme over time, and the comparison with the main candle test with the innovative arrays reveals that more announced patterns compared to the conventional main candle analysis. All of the implications in uneven rainfall threaten agricultural and water management. Also, the Belg season most prone to negative anomaly. So the recommendation implement the rainwater harvesting and irrigation system and focus on the climate resilient agriculture. In the final section, significant rainfall variability and the decline trends highlight climate change impacts in the area. So the call to actions like the urgent need for the data-driven planning and adaptation measure by the governments, NGO, and other committee were recommended. And the precipitation concentration index (PCI) indicate the dispersed distribution over the northwest lowland to the highland agricultural zones. Raising the awareness among the institutions and the general public is critical for effectively addressing the trends posed by the variability and climate change. This is all about my presentations. I thank you.
Thank you very much for that nice overview. Yeah, as said before, if you have any questions, please add them to the Q&A. Please also make sure that you write to which presenter that question refers to, so that makes it easier during the discussion that we can then directly address the speaker.
Thank you.
Thank you. And so now we continue with the next poster and talk. The topic is environmental impacts of drought, an impact-based approach using Google Earth Engine by Paula Serrano.
Hi, good morning. I'm Paula, I'm a PhD candidate, and as you already said, the title of my presentation is Environmental Impacts of Droughts, an impact-based approach using Google Earth Engine. Well, droughts significantly impact the environment and society, but the effects on ecosystems are often forgotten, as socioeconomic impacts are more direct. That's precisely why we chose this topic, and we conducted an exploratory pilot to leverage satellite and hybrid data so as to explore drought impacts in Andalusia, which is the southern region of Spain, to understand how drought conditions affect Mediterranean ecosystems mainly. That's why our main objectives are the assessment of environmental effects of droughts in Andalusia and the remote sensing data available, as well as its suitability and the potential of these sources to analyze and assess drought impacts. Ultimately, this study aims to demonstrate remote sensing potential, just as I said. Google Earth Engine has served as the primary source of data for this research, providing both satellite and model data that have been obtained on a monthly scale. The different environmental variables selected have been vegetation indexes such as NDVI and EVI, vegetation primary productivity, burned areas, terrestrial groundwater levels, soil moisture, and atmospheric dust presence. And that has been combined with drought conditions that were monitored using the SPEI index at different time ranges and monthly ranges, which account for SPEI 3, 6, 12, 24, and 48. And that remote sensing data was also complemented with official statistical data so as to serve as some kind of ground truthing process. Data was collected for 11 distinct natural and semi-natural land cover types present in the target area, including Mediterranean forests, shrublands, grasslands, meadows, agroforestry areas, and olive groves. The variables were then deseasonalized to identify the annual trends and eliminate seasonal fluctuations, enabling a statistical analysis to examine the correlations of drought and patterns and temporal trends, which has helped us to provide insights into how drought conditions affect different environmental variables over time. That all that being taken into account, this has led to certain preliminary results. The environmental variables chosen generally exhibit a stronger connection to short-term and seasonal drought conditions, particularly those marked by SPEI 3 and SPEI 6 in the target area. In particular, vegetation showed a stronger connection to short-term droughts, especially in periods of high vegetative growth, like in the spring season, as you can see in figure 1. This connection was higher when droughts are quite severe, which means that SPEI is lower than minus 1.5, especially for grasslands, which are particularly vulnerable to droughts due to their seasonal nature. Additionally, there's a strong connection of drought and fluctuations of groundwater levels, which highlights the essential role of groundwater bodies as a natural buffer to drought conditions, as they delay the sudden propagation of water deficits within the aquifer. All in all, the environmental impacts of drought in Andalusia manifest quickly in both vegetation and hydrological variables, with the shorter terms SPEI 3 and 6 indices showing the stronger correlations. Groundwater bodies exhibit a delay due to the buffering capacity of aquifers, and drought has a higher influence on vegetation in the target area, especially during peak growth periods in grasslands and meadows. These insights have allowed us to prove the high potential of remote sensing data, as well as hybrid data sets, which include both remote sensing and model data, to monitor and assess how the environment and ecosystem services are influenced by drought conditions. And it could also be used to enhance predictive capacity. Thus, remote sensing is a crucial tool which, complemented with a ground truthing process to validate the results, could lead to a better informed decision-making process. This study provides an initial exploration of the connections and impacts of drought, with a focus on identifying the impacts rather than quantifying them. In that line, more research needs to be done to deepen understanding of drought impacts and refine our approach for a more precise assessment, which would be essential for sustainable management and resilience. And we're currently working towards that objective. Thank you very much.
Thank you very much for that nice overview of your work. So again, if you have questions, please really feel free to add them in the Q&A for our copy and discussion session afterwards. I think that the next speaker is not here, or is Ajab Gul Mashidi here? Otherwise, if that person is not in the audience, then I think it makes more sense to then skip to the next speaker. In case the person still shows up, we're gonna have that talk afterwards. Because I did see that Karina is here, so I think we can then go to the next talk by Karina Osania on risk management in ports and coasts based on water sustainability.
Hi, everybody. Greetings from Mexico. Thanks a lot for this presentation. I present by my partner, David Segura, that it can be here, but I'm happy that be here with you. Thanks a lot. Well, our work is a gestion model for risk management, and we work is based on the analysis carried out of the importance of the water sustainability as the main means of health and well-being for human life, as well as sustainable development for ecosystems, which provide different environmental services and are essential component of the substance of the life of this planet. This is a priority to establish the necessary measure of the comprehensive and fair management for all members of the community. This work is proposed to a series of measures based on sustainability and the water management strategies from the continental part and the impact, and they have coastal areas, which allow for agile and efficient determination of the main risks described above to establish effective prevention and mitigation plans. This solution, in this case, were made for sustainable ocean management, require the application of the green technology and the innovative use of marine resources, and above all, sustainable management of water detritus. If we assume that sustainability is something that can be maintained by the itself, and the sustainable is a process that can be maintained without depleting the course, the question, or our question, was in the management of water and marine resource, important costs should be sustainable or sustainability when we're planning. Then I think that we must use both. Then we propose that environmental health in ports and coasts must be assessment to maintain the environmental services, which is very necessary to evaluate the integrated impacts of the accumulated pressure on the ecosystems and identify the risk, and could be arise in the port and coastal areas, such as gas emission, spills of hazardous substance. Others like expulsion of particles, ballast water, dredging activities, support construction, marine pollution, among others. Then we propose that environmental and managed policy to be or must be established for the governance and the water resources that reach port and coastal areas and the ecosystems, with the aim of minimize the human pressure and their impacts on marine biodiversity and the functionality of the environment when we maintain and sustainability provision of the natural services. Then this analysis show what the study area has a high degree of vulnerability, and the exposure, but this part is a part that protect the natural area. The pressure in this case for the human activities are low for this case, and it was determined that the system is very resilient against the threat for extreme weather events and the effects of climate change. We use a probabilistic and deterministic model for determination of the risks. We use in this methodology that we propose was based in the Hartman matrix. The Hartman matrix is a systemic tool. Then we use a systemic vision to integrate concepts of like circularity and positive and negative feedback. We eliminate to traditional vision that cause effect, and we take into account the role of the main actor of the identification of the process. Then we use the characterization sheet built with different templates that concentrate the information with the input variables that are physical and ecological characterization to establish the baseline, the definition of time and space scale, the definition of ecological and dominant process, the relationship of the system were defined, and with this environmental services with the main association vulnerabilities to determine with this the risk, the degree of vulnerability and the impact were determined. There we associate with a legal framework with a normative and legal instrument to give solidity and the adaptation and mitigation model and the matrix of social, economical, and environmental, normative, and political resilience. We include too. We include in the matrix and in the sheet good advanced practice that were documented to strategic continent plan, and the proposed this model consists of analysis the information to determine the main mitigation measure as a part that water the sustainability and relationship with port and coastal areas. First, we propose the review of water footprint for review the impact to the total volume of the fresh water used to produce the good and service, and we are consumed by individual community and establish awareness program to optimize the use of water resources in the basin. In second place, we propose measures to prevent pollution. This measure consists in raising awareness of the regulation of sustainability initiative for both public and private entities, as well as implementation of social programs that promote the collective behavior change for the responsible use of water and principles for life in the short, medium, and long term in all area. And number three, we propose protective measure for port infrastructure. The main sources of pollution in ports and coasts are urban wastewater, industrial wastewater, agricultural wastewater, gray water, and occasional discharge. So it's important to establish sustainability as planned appropriate measure which stipulate the requirements for this proposal. And we work in a case study that we define procedures to deal with emergency that can be or could be affect water resource and the environment, integrate strategic alliances, and produce sustainability reports to group interests. Thanks a lot.
Okay, thank you very much for the talk. Again, if there are questions, please type them in the Q&A. So then in the next part, we can answer them. So in the meantime, Ajab joined the Zoom session. So the next presentation will be on a novel multi-criteria decision-making tool for integrated offshore wind and wave energy site selection by Ajab Gul Mashidi. Ajab, I see you in the Zoom. Can you please unmute and start the presentation? Ajab, are you here?
Hello, good morning.
Okay, perfect. We're looking forward to your talk.
Thank you very much. Sorry, I was busy with many others. I didn't know that it is my turn.
No problem.
Hello, everyone. I'm Ajab Gul Majidi, a PhD student in the Faculty of Engineering of the University of Porto in Portugal. Today, I'm going to present our study, which is titled A Novel Multi-Criteria Decision-Making Tool for Integrated Offshore Wind and Wave Energy Site Selection. In this study, actually, we have the SWAN outputs, which is for 44 years. The SWAN model was forced with ERA 5 wind reanalysis, and for this part was used for the wave energy assessment, and for wind energy assessment, we use the ERA 5 wind reanalysis again, but with 100 meters height. In the analysis, the aim was to combine different parameters and decide which site is the best economically, and considering all restrictions that we had the data. In this multi-criteria decision system, in total 17 decision-making criteria, which are categorized in resource availability and complementary of the technology, and survivability under extreme wave conditions, and the logistics, which includes the maintenance windows, time windows, and grid proximity, and ports, and also the seabed characteristics like slope and the type of the seabed, which if it is a rock or sediment or anything, it was considered. And then the best worst method, which is a famous method, and the analytic hierarchy process was used to evaluate the composite suitability index. And at the end, the composite suitability index for the study area was analyzed in QGIS using the G-star statistic method to identify the potential areas. The key findings in this study was the northern and the central regions of the mainland Portugal, particularly around Porto and Lisbon, was the most favorable sites for offshore renewable energy sites. And these areas had the highest energy density and the low variability and manageable extreme events, which was analyzed. And the southern coast area near the Faro, near the Strait of Gibraltar, as you see in the plot, they were with the least favorable situation. And these results were aligning with the renewable energy concession zones, which are defined by the Portuguese government, which they are in 6 different regions. So our study also presented the same areas as the best possible places for wind and wave energy farms. And in conclusion, the study introduces a comprehensive multi-criteria decision-making system for the optimal selection of offshore wind and wave energy sites, combining the resources, technologies, and logistical and geomorphological factors. The system is validated also, as I mentioned before, with the 6 regions which are defined by the Portuguese government. And the findings underscore the potential of applying this method in different areas globally or locally in different places. And yeah, that's all. Thank you very much.
Yeah, thank you very much, Aga, for the talk. If there are any questions, please add them to the Q&A. I think the last speaker is still missing. So Christopher Wittmann is not here. So I would suggest that we just start with the coffee break session with the discussion. And I think to kind of kick off that part, I am going to read some of the Q&As because I'm not sure if everybody followed that they have been answered typing, and maybe if the authors are and the presenters are still here, maybe they can give some more insights. So I'm going to start with that one question that was addressed to Quentin about what is the procedure for the calibrated SWOT model for the bias-corrected data for precipitation and temperature. Quentin, would it be possible if you could give a brief summary to the audience?
Okay, thank you. Yes, for the soil and water assessment tools, I use the SWOT cup, which is another tools I use for both calibration and validation. So in that tools, we use the observed data to try to calibrate what the soil model has given as output. So the SWOT cup tools help us to calibrate the output of the SWOT and also to validate. So you have some part of observed data for the calibration and also some part of the observed data for the validations. After that, to check how far the observed data.
Voice is not audible.
Sorry?
We can't hear you that well anymore. Before it was really good, and now it's difficult to hear you.
Can you hear me now?
Yeah, now it's very good. Thank you.
Yeah. So we use some statistical metrics to evaluate what we had after the calibration and validation to see how far the observed data, the simulated data are close to observed data. And then for the regional climate model, we use I use the empirical quantity mapping method to bias correct the data I obtained from the Codex Africa archives. So the first step is to downscale for the catchment and then to bias correct the data based on the observed data of the catchment. Thank you.
Okay, yeah, thank you for providing these details in addition to already writing. So there's another question that has been written in the Q&A for Pan. What are the obstacles while getting data and running HEC-RAS 1D that consists of lots of data and section based on the field condition? So Pan, if you're here, it would be great if you could provide some details on explaining what the obstacles were.
Thank you for your question. Yeah, it is kind of My high-risk model is a long-term in this study. I make a long-term study, but for the hydrodynamics, I have no difficulty. This is because of also it is my study area is Japan. So they have rich of data. That is a good part of my study area. Maybe for the other countries, like maybe data is really difficult to get. For hydrodynamics, there is no problem because I have water level data for the downstream boundary condition, 1 hour interval for long-term long-term monitor data for the upstream river discharge and also for the calibration and validation. There are 4 stations along the river. So for hydrodynamic model, I had no difficulty of data. For the sediment transport, it is, of course, it is really difficult to get a sediment inflow rating curve sediment data. So that is impossible for me. So what we did in this study is we reproduce by changing rating curve because we have survey data, 200-meter interval survey data along the from 0 to 64 kilometer. So we use this survey data as a validation. So we reproduce by changing rating curve upstream. So it is kind of reverse calculation. So yeah, I think because of this data, I could I had no difficulty in this study. Thank you for your question. Thank you.
Okay, yeah, that's really nice to hear that you didn't have the problems with the data and that Japan has a very good base for that.
Yeah. I have one question.
Yeah. Mhm.
Hello.
Hello. Yes.
Pan, I have a question because you are studying in Japan, but in Japan,
Yes.
IRIC is famous. Mostly they use IRIC model to do sediment study. But
IRIC.
IRIC model,
Yes. I try because first my plan is to use IRIC because it is developed by Japanese professor. So my professor also recommended to use IRIC. But the problem is in IRIC, the riverbed material is only one type. So it is only one reach, same riverbed material. My study area is from 0 to 64 kilometer, as I show in the poster. The riverbed is different. I mean, upstream part it is gravel, middle part sand, and estuary because of tidal transport, it is like a sand, brine sand, and the mud. So that's why I decline IRIC model because it is also 1D. I could use IRIC, but because of that riverbed material is different. So we have a 64 kilometer, but in IRIC only one option. Same material, the whole river. So it is kind of like, well, I think it is my opinion. It is like reach scale or same riverbed material if we have a riverbed material. So I chose Hagras. Yeah, it is very, very, very interesting question. Thank you very much.
But there is any study that compare results of ICRAS model and IRIC model?
Compare? No, I haven't tried.
Okay.
Thank you very much for your question. Thank you.
Okay, yeah, thanks for answering those questions. There are still, I think, 2 or 3 more that I can read from the Q&A. So there was a question for Martik. What is an expected resolution of LULC that we can get using this method? Can you maybe just also answer that question for the whole audience again? Thank you.
As it is done in Python, the option for downloading the image, there is an option where we can give any resolution we want. Like I can give 10 meters or 5 meters also. But I'm not focused on how the variation resolution changes the results. But I've downloaded the results in the same resolution as that of the input, which is 30 meter of the Landsat data.
Okay. Yeah, thanks for providing that addition. If also another note, if there are any follow-up questions, please feel free to type them in the Q&A so that we can also then read them. Then I'll continue. There's a question for Elias. Did you consider RS open data source for evaluation of precipitation in the volatile zone because there was a lag station in most part of Ethiopia, including that zone?
Yes, I appreciate these questions, but as I tried in the chats, I used the models or the Markov chains inputting technique used to field the field stations, and also additionally before collecting the data, I focused on the available stations. That means there is more than 15 station, but I only focus on 10 stations. That means data available station in the region, and also they have less than 20% of missing data. So, and additionally, I cross-checked and correlated with the Power NASA datasets, and I did that part in the objective and another objective, and also that's paper also in the under process and or under review. This is the part of that, and also one have been published, and I put the link in my access that articles in online from Helion's journal. Thanks for your nice questions. I hope he got some clarifications about this.
Yeah, so thank you very much for answering that and also for providing the link. So anybody interested, please see the link to the paper in the Q&A chat. And then there's a bit of an open question. I'm still going to ask it because maybe some other people are interested in. So that would be more for example, Eva or Michael to answer. So there's a PhD student and he's interested, or that person is interested in submitting an abstract for the IAHR Congress in Singapore. And is there any financial support or are there grant opportunities for students to still attend that Congress? Can maybe someone help me with answering that question because I don't know.
Yeah, me neither. Actually,
Okay.
I can try to answer. Well, first that the abstract submission will end this week, and then we will have some time for the special session, and this will be promoted later on. In terms of financial supports, there are some different costs for low-income and high-income countries for the registration, and it's everything on the website. But apart from that, I don't know. Probably the best way is to contact directly the organizers.
Yeah, thank you very much. So yeah, if you have questions, please
probably
just
also add to that
perfect.
Very often, once you've submitted an abstract to a Congress, you can get some funding from your national science organizations or from your university. So maybe that might be an option. So
yeah, that's a good point. And if you're in doubt, contact the local organizing committee of IAHR in Singapore or the secretary of IAHR. Yeah, there are no more other or open questions in the Q&A. Again, feel free to still add them. Other than that, Ravindra, do you have some more questions or I'll give over to you?
Because still we have 10 minutes left. So besides this presentation also, anybody want to ask any question because a lot of people are here. So they can ask. Because we have presentations on risk assessment, landslides, then climate change assessment. So any other interested in other question also they can ask. I think there is no question. Then can we wind up? Hello. Hello.
Yeah. Are there any more questions from your side?
I think there is no question. Then can
Yeah, if there are no more questions, then I think we can close that part, and then people can use the remaining time to really get a coffee and get prepared for the next session and the next interesting talks. So thank you very much again from my side for all these interesting posters and nice overview. It was really interesting also for me, since I'm not exactly from that field.
thank you very much, Isabella, then Michael and you, madam. And I congratulate every presenter for nice presentations and nice question answer. Thank you very much once again. Have a nice time. Please enjoy the next session, technical sessions. Thank you very much.
Thank you very much.
Thank you very much also from us, from the organizing committee. Thanks to you as the mentors for chairing this session, Isabella and Ravindra. And we will commence for the next session in 15 minutes. So really get a coffee and have a break, and we'll be back for the next session. And please, those people who are speakers in the next session, put your hand up that we can promote you to panelists here. Thank you.
Thank you. Bye.
So as we're about to start the next session, could please all speakers for the next session who are not yet promoted to panelists, put up your virtual hand so we can promote you. Thank you. Are the chairs for this session already here so we can start?
Yes, we are.
Yes, wonderful. So,
Hello,
welcome to the
everyone.
next session. Over to you, Amparo.
Hello, hello. And Paola Krip. I think she's not here. Okay, so we can go on with this topic of climate change adaptation, in which we are going to speak about very important topics related to rainfall, hydrology, modeling, eco-hydrology, and water and climate change. So if you agree, we can go passing for the first person who's going to present, which is Sebastian Tapia. Is Sebastian here? Yes, he is. So you have 6 minutes, please, Sebastian.
Okay. Okay. Hello, everyone. Well, I'm Sebastian Tapia. Manchego. Well, the title of this presentation is Future Precipitation and Temperature Trends in the Regulated Chile System based on SSP 1.26 and SSP 5.85 scenarios of the CMAP6 global climate models. Well, this study analyzed the precipitation and temperature projections in the regulated Chile system using SSP 1.26 and SSP 5.85 climate change scenario from the CMA P6 global climate models. Made a statistic bias reduction methods were applied using empirical quantitative mapping for 13 subbasins and based on the historical data graded from the PISCO product. Well, the methods for this research is that this study focused on the regulated Chile system situated with the upper sections of the Quilca, Victor Chile, and Camana basins. Comprising 7 dams critical from Arequipa, so water supply. Arequipa is in the south of Peru. Due to limited hydrometeorological data, use historical data from PISCO dataset, that is Peruvian interpolated data of tsunami climatological and hydrological observations. The study divided in 13 sub-watersheds, and I tried to I analyzed the evaluation of 26 CMAP6 models, and then I correct the bias in precipitation temperature projections using an empirical quantitative mapping, and select the best fit the bias percentage of that both scenarios. So the results give me 80 global circulation models. Show minimal bias against with PISCO data, reducing discrepancy across 13 subbasins. So In the SSP 1.26 scenario to 2100, the highest subbasing, the precipitation increasing 11.4% and the temperature increasing 26%. The lowest subbasing and the precipitation increasing 5.4% and the temperature increasing 14.75%. And the worst scenario, that is SSP 5.85 is a scenario to 2100, the highest subbasing, the precipitation increasing 27.65% and the temperature increasing 54.55%. And the lowest subbasing, the precipitation increasing 12.35% and the temperature increase in 31.35%. Well, the historical average between 1981 to 2014, the wettest months in the worst scenario, that is 114.76 millimeters, rising to 165.77 millimeters, that is in February. And the coldest month with a worst scenario, the temperature that is 2.63 degrees centigrade, increased to 6.6 degrees, that is in July. Okay, the conclusions of this research that show us the increase on precipitation and temperature in both scenarios with greater variability and potential extremes. Water infrastructures and manage in the Chile system must adapt to this change. Proposed include engineering a natural-based approach, such as permeable reservoirs called cochas here in Peru, conservation and restoration of high Andean wetlands called bofedales, infiltration trenches to enhance water storage and regulation. This leads to the groundwork for assessing climate change and land use impacts in water resource management in the Chile system using hydrological model. That is the next steps of this research. That's all. Thank you.
Thank you, Sebastian. Do we have any questions for Sebastian? I have a curiosity because you have made some future precipitation with a series, but you have had a lot short time to prove if more or less this is happening. Do you have any way, any idea of validating this in the short term? Can you make any comparison with the next years? Do you have any idea about the accuracy of your predictions?
Well, honestly, no, I don't the idea how to evaluate with a shorter periods, but I think when we are going to evaluate, I'm going to evaluate that with the nearest period, the midest periods, and the future periods with a historical average that is around, I think, 35 years that I use for the historical data to compare it with that.
Okay, thank you. Thank you, Sebastian. Any other question? Okay, so thank you. We keep for the coffee. Maybe in the coffee we have some more chance to chat. And now we present spatiotemporal assessment of project response evapotranspiration and the climate change. Who's going to present now? David Bolonio or maybe Famse Sarad Mutsarabisadeh? Okay. So Do we have any person presenting this paper? Okay. So we go for the next one. Maybe we have this contribution later. The next one is hydrodynamic simulation of water flows and exchange processes in Lake Shwilochsi. I don't know if I said, I would, which is Can Olmes. Hello, Can, welcome. The
Hi,
floor is
thank you.
yours for 6 minutes, and then we will go.
Yes, yeah, thanks a lot. Good afternoon, everyone from Berlin, here in Germany. And also, yeah, thank you for the opportunity to present the work on the hydrodynamic simulation of Lake Shwilochsee here. The work I did here with the hydrodynamic model is embedded in the project Spreewasser N, and the Spreewasser N it focuses itself on projection of the consequences of climate change and the phase out of lignite mining in the area, especially in the Spree catchment. And you may know the river Spree is the river flowing through Germany, through Berlin. And as mentioned, the Lake Shwilochsee is the main focus of work here. It's located about 70 kilometers southeast of Berlin. You can see this here in the minimal map view here. There's a small black rectangle on the situation of the lake. And currently the Spree contributes about or even more than 90% of the lake's total inflow. Can see that also here on this map view at location C. And you have to know that the region is one of the driest regions in Germany and will probably also face some of the significant climate change impacts, including drought and low water flow periods. And furthermore, we have a large lignite mining history in the East German Lusatia region. This also significantly modified the Spree catchment over the last 120 years. And today the Spree flows in an unnaturally wide and deep profile with mining discharges account for about 50 to 75% of the total discharge in the Spree River. And we all know the Paris Agreement. A product of the Paris Agreement is that the lignite production will phase out or cease by 2038, and mining discharges will then stepwise reduce to zero by 2070. And you can see here in figure 1 that the water volume discharged from the mining activities into the Spree, they also show some political activities here. I try to indicate this with a red dotted line. This one shows the reunification of Germany, which was formerly divided into East and West. And after the reunification, we had also already a decrease of the volumes discharged in the river. And this reduction also has significant society and economical and also effects on the ecosystem. And this also includes a safe water supply to the city of Berlin. And to sufficiently manage the water needs, there are currently different ideas discussed. And one of this idea is that Lake Shwilochsee could be turned into a near natural reservoir. And to have like a model to analyze this, I tried to set up this Shwilochsee lake model and also tackle some of the research questions you can see down here as well. So my ideas were like, what influence do different flow regimes have on the flow dynamics, and how can also different findings from water transfer scenarios be transferred and give an insight on how the lake would behave as a water reservoir, and then where's also further need for research. And I conducted all of this simulations with the Telemark 2D model. And I brought one scenario I would like to highlight here in this map. On figure 3, you can see on the left side the current mean discharge condition, so the MQ scenario. And we have a large exchange, especially in the northern part of the lake, where we have a large inflow at location C and an outflow at location D. And on the right-hand side, you can see what's considered to be a future summer flow condition, and also whether installed water transfer at location A. So about 2 cubic meters per second are transferred from further upstream of the Spree, and we have like this bypass trying to avoid losses through evaporation of the Spree water. And then we have a boundary condition at the outflow D set to 8.5 cubic meters per second, which is the minimum water or minimum discharge required to sufficiently maintain the safe drinking water supply for the city of Berlin. And yeah, my calculations show that in this summer conditions and also with a fully filled reservoir, we could maintain the minimum discharge for about 27 days. And what's not shown here, but what I can give you as a takeaway is that the mean water discharge conditions, they take up to 41 days to fill the lake up, so when it's when the reservoir is emptied. And yeah, one thing I would like to give you as a takeaway is that upgrading the Lake Schwilowsee to a near natural reservoir can help to sustain minimum discharge conditions, but should definitely not be seen as the standalone solution here, and should be also only be part in an adaptation to this, an adaptation in a series of different measures. And some open questions still remain on the exchange with the groundwater flow, and also some ecological issues are to be solved. Also, with regard to the historical mining activities and increased sulfide values and etc. So yeah, with that being said, I thank you for your attention, and yeah, I'm open for some questions.
Thank you, Kan. Is there any questions for this presenter? No, I don't see any question. I am curious because you present a model making some future considerations, transforming a lake into a reservoir. And I have two questions. First, to do so, you make a model. How is your model? Is it a numerical? Is it a finite difference? It is a commercial one. How do you model this thing, Kan?
I used the Telemark 2D model with a shallow water solver and depth averaging over the lake, and I used the finite element method that's implemented in Telemark.
You developed this model in shallow water questions and so?
Yeah, the Telemark model is available, and yeah, I used it. I used the code from Telemark to develop the model.
So you present the model, and do you think that this possibility could be real? Would you have this in general a good support in your environmental things related to changing with these lightning problems or possibilities and so? Do you think it could be really done?
Well, that's a tough question, actually. Yeah, as I mentioned, there are different solutions currently discussed, and also the results presented here, they're part of this project, the Spreewasser N project, where different stakeholders are involved. And yeah, it's in the end a political decision on the one hand, and on the other hand, so the 27 days I calculated, they're like a small add-on. It should be definitely, I mean, what's also currently discussed is like inter-basin water transfer, and also building up storage volumes in all over the catchment, so to have like a cascading effect. And what's also maybe interesting to know is that this whole catchment is hugely modified. It was hugely modified in the past due to these mining activities. So we're far away from natural flow conditions now, and we're just trying to adapt to the historical changes that came with the mining activities. I hope that answers your question.
Not easy to answer the questions because it's a thing could happen. Who knows? Okay, so thank you very much. No more questions for Khan? No. So now we have the next one, which is investigating rainfall variability in the Okhotsk region using information complexity metrics, which will be presented by Basel. Hello, Basel. The floor is yours. Thank you.
Yes, thank you very much. So thank you for joining this session today. So I am Mohammed Basel Al-Sawaf. You can call me Basel from Kanazawa University in Japan. So let me just proceed directly to the title of my work. So as you can see, investigating rainfall variability in the Okhotsk region in Japan using information and complexity metrics. So as you may know that the notable shift in the current global climate caused different patterns of heavy rainfall events over the world. So also given the stochastic nature in the rainfall records, so there is a necessity for a comprehensive assessment of rainfall patterns. So we should classify them either extreme or non-extreme, which is very important in order to improve the current flood mitigation plans. So in this study or in this research theme, so we aim to investigate the variability in the annual rainfall patterns in the Okhotsk region in the Japanese part using a combination of information and complexity-based approach. So let me just proceed directly to the methodology that we performed in this study. So in brief word, the methodology, as you can see in the first figure on the left-hand panel, contains 5 main steps. So in the first one, as you can see in the red box, step number 1, which is data collection. So we collected data from different stations, meteorological stations in the Okhotsk region. So today I will just show the case of Kitami station. So we collected daily rainfall data from different for 40 years, from, as you can see, 1980 to the end of 2020. By this data, then we determined the threshold, and in this case, we used the median rainfall, daily rainfall value as a threshold. And by this threshold, then we go to Boolean conversion. So in this step, we converted the daily rainfall data to a binarized sequence. What I mean by that is 0 or 1. So for example, if we look to the time series in the first figure, on 15th of August, we can see that the recorded daily rainfall data was 40.5 millimeter. So this data, if we compare to the median rainfall data, which was 6 millimeter, then we found that this is greater than the threshold when it was mapped to 1. However, if we consider another data, for example, 14th of August, then it was 0 millimeter. So this value was less than the threshold, then it was mapped to 0. By this step, then we go to the second step, number 2. So we have to define word length, and in this study, we selected word length of 5 characters. And since we are using only 2 characters, 0 or 1, so the possible number of encountered words per year is 2 power L, which is equal to 32 words. So each word here represents the pattern, possible pattern that can be observed, of rainfall that can be observed each year. So, for example, if you look a little bit in the first figure, we can see a series of binary spikes, 0101. If you consider the first rectangle, continuous rectangle, so we have the first word 00011. So for each year, we calculated how many times per year do we observe this pattern. And then we shifted the window by 1 character to the right. Then the new generated pattern is 00111. Then again, we try to determine how many times we observe this pattern per year and so on. Once we do this, we calculated all probabilities per year, and then we estimated Shannon entropy. And by that, we can proceed to the final procedure or final step, which is calculating the information or randomness, which is mean information gain and the complexity measure, which is effective measure of complexity. Now, if we look to the figure number 2 and having some image about the statistical data, so figure number 2 shows the time series of the total annual rainfall over the study period. So, of a great importance, by visual inspection, we can recognize a slight shift or increasing in the total annual rainfall values since 1988 and onward. So we have documented around 150 millimeters increments per year of the total annual rainfall. Now, if we go to the results of the annual variation of information and complexity scores in figure number 3, we can see that most of the years at Kitami Station, they exhibited almost comparable patterns. However, 3 years stand out. The first one in 1995, and this year represents the highest year with mean information gain or randomness. The other year can be seen is 2019. This year represents the least or the minimum value of the mean information gain. And the last one, which is denoted by the yellow color in 2016, got the highest score of effective measure of complexity. And to provide a clear understanding about those specific years, let us look to table number 1. So this table tells information about information and complexity scores and number of rainy days per year exceeded the median threshold. So first, in the case of 1995, so we can find it scored the highest MIG or the highest value of information. And we observed that during that year, we got the highest number of days that exceeded the median value. So we have 60 days of huge rainfall, daily rainfall in 1995. Now, the opposite case, if we can look in 2019, so the MIG value was around 0.3 approximately. So during that year, we got the minimum number of days that exceeded the median rainfall. So we have around 21 days per year. However, in the case of 2016, so we got the highest value of EMC or effective measure of complexity, around 0.34. So we found that during that year, so it indicated a large number of consecutive days with rainfall exceeded the median rainfall. So in other words, if we followed some reports published by the Meteorological Agency of Japan and other researchers, we found that it was documented that 3 consecutive typhoons in 1 week or in single week occurred and caused record-breaking torrential rainfall in Hokkaido for the first time. So by that, the main conclusion that can be addressed for this research team or this study is that the annual rainfall patterns in the Okhotsk region did not change considerably. However, there is an increment about 100 millimeters or 150 millimeters per year was documented in recent years. Another thing is that information and complexity measures are very powerful in order to disclose the internal patterns. So we could, by this methodology, understand the days that exceeded median rainfall and the days with least huge rainfall. In addition, we know the pattern itself, like in 2016, we understand that extreme pattern of composed of 3 typhoons occurred during that year. So another important point of this study that this method can be transferred to other approaches, other systems, for example, soil moisture or weather temperature, so it can be used to investigate the hidden patterns of those dynamical systems. By that, I reached the end of my presentation. So if you have any question, any comment, it will be more than welcome. Thank you.
Thank you, Basil. Do we have any question? No question? Well, I have a curiosity because you used a technique in which every year, in every consequent consideration, the accuracy of the system was better. I think you were like training the system, isn't it? What you did?
It's not training, but we just consider year by year. So we can then compare each year to another year. So we can have a table and then we can find the similarity and dissimilarity between the patterns that occurred each year. So yeah, as you said, so we find in 2016, for example, different pattern. In 1995, we have different pattern, but other years we have almost, we can cluster in the same group. So yeah, exactly. It is beneficial approach for disclosing those patterns.
And the improvement was very good because the days in which you were out of the range were improving very much. This is the sort of things that some sort of automation with neural networks or with artificial intelligence or with something will help you. Did you use any of this sort of digital helpers to do so, or do you have it in your mind to use it in the future? Because it is one thing in forecasting that can be really easy to make some sort of adaptation by thinking, by learning in terms of artificial intelligence. Do you have this in your mind for the future?
Yes, exactly. So we want to improve, for example, the selection of threshold. So here in this study, we use the median value as a base to judge the severity of the rainfall pattern. But in future, we need to incorporate some approaches, like, for example, IDF curves or other approaches, as I mentioned, digital methods, in order to improve the accuracy of selecting such threshold. Then we can identify, for example, which daily rainfall was really extreme or not sufficiently. Thank you very much.
Yeah. Thank you for you. I like very much your presentation. Does anybody has any other comment? Okay, so thank you, Basil. So the next presentation is modeling eco-hydrological partitioning in a tropical dry forest in Costa Rica. I think it is going to be presented by Mohamed Sokrolahi. Hello, Mohamed, welcome. And thank you
Hello.
for your time. The floor is yours.
Thank you very much. I'm starting. Okay. This article is about the modeling of hydrology fluctuation in tropical dry forest in Costa Rica. I explained some things about the abstract. This study investigates how the plants in tropical dry forest in Costa Rica adapted to the droughts, and it's aimed to understand how the plants extract the water from the different soil layers. And particularly it's the water strategy and the roles of the facultative decisions in the drought avoidance. And however, also it's a strong relationship between the tree behavior and soil, water, and in the end, to make the ecological predicting complex. Okay, I try to explain some things about our study site. Our study site is a tropical dry forest in north of the Costa Rica, and we use the two type of the trees. One of them is the rondon, and another one is the guasimo. And we use the precipitations data in the nearby stations. Its name is ERA 5, and you can see in the pictures A. And another things our measurement data, we use some methods to measure the subflux data and soil saturations. And all these models and simulation, we use the SUR eco models. SUR eco models, all of them we use the R program, and we write all the codes in R program, and all the graph all of them is created for R programs. And all this data, it's collected by Isodrones Group. Isodrones Group they are in our university, in Technical University of Braunschweig in Germany. So I started to explain some things about our figure. We can see the sums. We can see the indicate some comparisons and the models and observation in the different time series, such as sap flow velocity and effect of the soil saturations. And we can see the black line is the simulated data, and the green line is the observations data. And in the in both of the three, in the first graph in B and C, you can see in the both trees, both Ron and Guasimo, we can see the significant drops in the start of the dry season, and after that, again return to the normal yearly levels. And as you can see, it's a good correlation between the soil water content in a different soil layer, but it's some disagreements. It's related to the precipitation data, but some disagreements is related to this precipitations data. And another thing, it's so important, it's the faculty decisions in the soil water content in all layer. It's related to the environmental condition. But it's a report that the wrong trees, wrong type trees have shadings every 2 years. But the Guasimo have kept the leaves wilted for a long period and still transpiration. And as you can see, the wrong is the left and the Guasimo is the right. And you can see the higher transpiration rate in wrong is related to the have a bigger trunk or bigger leaf and can adjust the leaf shadows. Because of that, have a lot of LAI size. And this models needs to develop for three physiological and eco-hydrological process in the regions. It's all of them. I try to explain more quickly, because about the time, I think it's only 3 or 5 minutes. I see this. I have a time to explain all of them. It's finished. I am ready for all of the questions, and thank you for your attention.
Thank you, Mohammed. Any questions for Mohammed? No. I have a curiosity, because this simulation or these predictions you make about the needs of the plants, you think that you model and you see that there are, well, your model needs more improvements, but do you think the model you are doing is really accurate enough? Because I see many uncertainties in this sort of modeling. Do you think that the predictions you take so will be accurate? Which is your feeling about that?
That's a good question, but I think I should work on because these models have a lot of parameters. For example, it's more than 100 parameters, and we should change all of them in for any trees. And as I understand your questions, I think it's not only the predictions for all the future. Only this one is for 2 or 3 years. But in futures, I have plans to predict things about the tree mortality and some things about the wildfire by changing the some parameters and make a good correlation and validation. And this I use the Sur Eco version 2. But our groups are developments the Sur Eco version 3 now, and in summer they want to development to version 4, and I can use that to predict and improve that.
And Which are your future plans to do with these results?
About my futures, I want to use to predicting the tree mortality and the wildfire in some yes in some in some forest in Europe only, because all of them is from the Costa Rica and from the tropical dry forest. What we used and write some articles in to use that to predicting about the forest in France, I think, in futures and the tree mortality. But we want to compare with another trees. Okay, thanks so much.
Okay, thank you very much. So we give the pass to the next one, rewilding for the protection of coastal areas. Do we have any presenter?
Yes, I am here.
It is David.
Yes.
Oh, hello. David, thank you very much for your time. So now it's your time.
Thank you. Good morning, everyone. I will talk to you of rewilding for the protection coastal areas. Mexico is located in one of the areas with the highest exposure, to multiple phenomena worldwide, such as extreme meteorological and oceanographic and geologic events with the serious consequences, including the loss of human lives or the damage of the public infrastructure, among others, which especially affect with the most vulnerable population. Mexico, there are regulations relate the components of the environmental protection in ports and coastal areas, which are shown below for the formulation of this type proposal. These are multidisciplinary and multidimensional solution, science different environmental, social, economic, political, and regulation components intervene. In the long term, these types of measures will be much more effective in the presence of the extreme hydrometeorological events or adverse effects due climate change. The proposal is integrate using water management as a tool, reforestation of the dune system with endemic vegetation. They implemented as seagrass using artificial reefs. The long-term benefits are the use the components of the marine ecosystem. The long-term benefits were modeled with the UNBIST LT program, planning, harvesting, and more monitoring programs of the ecological barriers with bivalve mollusks were proposed to the roost cones and all of the accumulation of the sediment and species in the ecological reserve area. For the last one, for this project, we need alternatives were proposed that are based in the concept of the rewilding supported by ecological barriers that allow maintaining and where appropriate, improving the environmental and coastal surroundings, using elements and materials that favor recovery and coastal dunes, reforestation with dune vegetation, and they use artificial reefs that favor the deposit and sands in areas proposed for filling. It was also proposed to resource prefabricate elements already built and evaluate in the area the create barriers and not building new elements was manufactured will cause an economic and environmental impact. This is a project with Mexican Transport Institution. Thank you so much.
David. Well, it is a very interesting project and very interesting results. So as I assume you make some proposals for rewilding, and in which degree are they implemented now? Are just in project, or are you going on? Is it on the way? Where are you in this moment?
Is sorry, is just in project.
It is in the project phase. And do you think these sort of actions are welcomed by the local population? Because sometimes we have this problem that we propose technical solutions and then they are not very feasible. Which is your feeling? Do you think it will be done? Do you think so?
Yes, we have.
Yeah, you have a good feeling. Okay. Do we have any questions for David? No? Okay, so thank you very much, David, for your presentation and for your time.
Thank you so
And
much.
now we give pass to the next one, shifting soil microbial co-occurrence pattern and the permafrost degradation, which is Sue one. Hello, Sue. You are just waiting for presenting.
Thank you very much for the introduction.
Yeah.
Good day, everyone.
The floor is yours.
Yes. I'm Zhu Wang from the China Institute of Water Resources and Hydropower Research. And today I'm honored to share our research on shifts in soil microbial co-occurrence patterns and the permafrost degradation in Qinghai Tibetan Plateau. Let's start with some background. Permafrost, as you know, is ground that stays frozen for at least 2 consecutive years and is widely distributed across the Qinghai Tibetan Plateau. So the permafrost plays a critical role in maintaining the structure and function of cold region ecosystems. However, climate change is rapidly accelerating permafrost degradation. One of the most visible consequences of this process is the thickening of the active layer, which is the uppermost soil layer that undergoes seasonal freezing and thawing. So why do we focus on microbial networks? Soil microbes are not isolated entities. They form intricate co-occurrence networks, interacting through cooperation, competition, and niche differentiation. These networks can reflect ecosystem functionality and resilience. So by studying microbial networks along a gradient of active layer thickness, or ALT here, we can better understand how these communities recognize and reorganize under environmental stress and maintain the ecosystem processes like nutrient cycling. So our goal was to uncover how microbial interactions shift along a gradient of ALT in the Qinghai Tibetan Plateau. Especially, we wanted to identify the key taxa driving these changes and understand the ecological roles they play in adapting to the permafrost degradation. So we choose 4 plots in the Qinghai Tibetan Plateau, each with different ALT levels, ranging from less than 3 meters to more than 4 meters. We collected soil samples, extracted DNA, and used high-throughput sequencing to study microbial communities. Then, using the iLab approach, we built the co-occurrence networks to examine how microbes interact with one another. And here's what we found. For the plot LD, the ALT was less than 3 meters. The microbial network was simple and stable. The proteobacteria, shown as the pink one, dominated in this network, which suggests that there was functional redundancy and is kind of stable in this microbial community. And for the plot MD, the ALT was 3 to 3.5 meters. the network's complexity increased, we can say. And we saw the main taxon changed to the chloroflexi, this kind of taxon, and as the core taxon in this community. And it shows a kind of adapting to the changing environment. And then this one, the chloroflexin, often linked to the decomposition of organic matter, which may indicating that with the permafrost degradation, there should be more microbes to decompose the organic matter in this ecosystem to fulfill some kinds of ecosystem function. And for the plot HD, the ALT was 3.5 to 4 meters. The network become more integrated, and they show niche differentiation and resource partitioning as they adjust to new conditions. And finally, to the ED plot, the ALT was greater than 4 meters. We can see the network was highly complex with firmicutes and actinobacteria co-dominating. This indicates a resilient and cooperative community that supports the key ecosystem functions, even under this intense environmental stress. So in conclusion, our research shows that permafrost degradation significantly alters the microbial networks and increasing their complexity and diversity. This helps stabilize the ecosystem in these fragile regions. These findings are kind of the essential for understanding the carbon and nutrient cycling in the permafrost affected areas, and they highlight how microbes adapt and remain resilient under the climate-induced stress. And thank you all for listening, and I'm happy to answer any questions you may have.
Sue. Any questions for Sue? Okay, I have a curiosity, Sue. What do you think that are future implications of your findings? Because I see that permafrost stability is quite important for oceans in actual situation, but climate change is changing this. So in your opinion, as a young researcher who has a lot of years to see, what do you think these are the implications in these changes that you are registering?
In my research, we can see that only with the active layer thickness changing from 3 to 4 meters, the network of the microbes are changing hugely. And the most important thing is not just a stop in my research. It's I need to go further to detect what kind of role those kinds of core taxa are playing in each kind of the ecosystem, and the specific function they were playing in this role to may go further to explain why they are changing and what they are doing for this ecosystem. I think this is the most important thing in this field. That's my answer. Yeah.
Any questions for you? No? Okay. So we have the next one, whose estimation of clear water score depth around bridge piers, a study using Mars and 3 machine learning techniques, which will be presented by Anup Bharawat. Thank you so much. The floor is yours.
Hello, thank you everyone. My name is Anubhav Barnwal. I am going to present my topic on estimation of clear water score depth around bridge pier. A study using 2 different type of machine learning technique. The first one is Mars, that is multivariate adaptive regression spline, and second thing is that M5 So this 2 technique has been utilized to predict the scour depth around a bridge pier under a clear water scoring condition. As we know that due to the local scoring, lots of bridges has been failure due to the settlement of the bridge pier. So in this technique, a prediction has been done by utilizing of these two techniques. In this technique, we have collected total 438 previous published data set of the various literatures, and in that data set we have to divided the data set in 75% for the training purpose, that is 328 data set, and 25% for the testing purpose. Later a gamma test has been performed to identify most influencing parameter which is directly related and influence to the score depth. So due to the utilization of gamma test, it is found that pier width ratio with respect to the flow depth, V by VC, that is approach flow velocity with critical flow velocity, critical fault number, and V by density and standard deviation of the bed sediment. That is the combination of all these parameters is the most influencing parameter to predict the score depth. Then after that, the developed model performance has been checked on the basis of 5 to 6 different statistical indices. That is a mean absolute percentage error, root mean square error, coefficient of determination, and rest of other. Then what models result shown that is compared with previous available empirical equation, that is Coleman 1971, Colorado State University CSC equation 1975, and Yanmaz equation to check the reliability and of the developed model results. So in that result, it is found that after the application of the Mars and M5 tree model, it is found that M5 tree model predicted better compared to Mars model. Later, it is compared to previous available equation. Again, it is found that what Mars model predicted, that is predicted near about the score depth around the base fit line. So that model which is developed, that is compared to previous author, and later when we concluded that this M5 tree model is better, then we applied a Powell to 2019 field data set. On that again we checked that which model that is developed, that is again how it behave on the field condition. So in this current different tuning during the development of the model, different hyper tuning has been done by for Mars model and M5 tree both model, and later in that case it is found that after 50 around 40 to 50 simulation, it is found that on which value in which Mars in Mars hyperparameter where membership function and instances is minimum, and in case of M5 tree model, number of rule and minimum instances is taken at 10 to 40 and minimum to -1 to +1. That is be giving better result. Through a scattered graph has been plotted in which we can see that in M5 tree model which predicted on the field condition near about the best fit line, and later it is found that in case of Mars model it will be over predicted, and Coleman empirical equation again under predicted. So it is concluded that the poor performance of the empirical equation is that maybe these equation has been developed for a different range of data set compared to present range of data sets which has been selected for the modeling purpose. And in compared to both empirical model, both machine learning model, it is found that a Mars model, M5 tree model has been given better result compared to Mars model and other compared to empirical model. So, and all this result is decided by on the basis of statistical insights. That is here we can see that for the Mars model, RMSE value will be 0.10 and R square value, that is coefficient of distribution around 0.875, and M5 tree it will be better. So error in that case is minimum. So it can be concluded that the M5 tree model will be better, and this model can be utilized in the field condition also when data set has been range of the present data set range which is selected for the modeling purpose for the present study. So that is all from my side.
Thank you, Abuna. Any question for this speaker? I have a curiosity. One model is better than the other. You agree that there is one better than the other, but if you should make a recommendation for designers, you really recommend this one in front of any other models? Do you think this is in any aspects the more reliable?
If a data set like this model, we have to collect it for 38 data set. If data set in that range, like if we in present case DSY Y, that is coordinate ratio. If data set in that range, then we can say that EM5T model can be utilized in the field condition. If data set like B by Y, B by BC, whatever data set we had taken to develop the model in the field condition, if data set within that range, so we can say that this particular model can give a better result. So we can make some decision on the basis of that. If data set should be in that range.
Okay.
Yes.
Any question for the person to Anubhav? Yes, we have a question. Could a study using a physical model bring better results than the method used, or they are equivalent?
The study using physical model bring better result than the model. Are they? In case of machine learning model, we can say that its accuracy 90%. We have to like a prediction, not a exact result. So on the basis of, we cannot say that as a physical model, whatever value we getting from through the experiment, same value we can get through machine learning model. It is like a prediction like thing. We can 90% can predict, but we cannot 100% sure this thing, same thing is going on. What is in the experimental study, same thing we can find out. So on the basis of that, we can like predict 90% probability that this model will be better, or this score that will be happen if our input condition like a flow velocity, flow depth, like all these things is like this value. So we can predict and its reliability 90%, not 100% sure.
You
Yes.
have some more questions which you can't write the answer, but they say why you use old formulas, not new research.
No, actually, these formula, I check the reliability of available these formula. Previously, lots of authors directly use this formula to predict the score depth. So currently, after the modeling, we compare the reliability of present model compared to previous available equation. If previous available equation given better result, so no need to go to machine learning model. So because they already equation available, they are giving good results. So for the present range of data set, we check the previous available model, that is empirical model and present model. So compare a result of both. So it is find that whatever previous empirical equation which is available in previous literature, that not given a good result in that condition. So this is the yes.
You will have the chance to answer because the person at C asked why is it, but you take your time later to answer.
Yes.
And there is another person who says that the comparison is only shown at only one value, and it is hard to ensure the agreement with all the best fit line. Did you consider more values along this fit line?
Yeah, actually, model is set up. Firstly, we train the model, then test the model. When we concluded that on the testing, this model will be better, then we have to take a separate experimental experimental data, field data that on the scale of that set up on experimental study. On that, we have to decide for taking another at that value which is not a part of the model purpose. Outside of the modeling data set. Then I try to check whatever model I concluded already, that in new data set how it behave. So it is find that like taking one data set, some other data which is not a part of model, but within the range of that data set which is taken for the modeling purpose. So just showing for that one data set, and it is found that that model behave a good result. So that's why taking one data. Yes, ma'am.
Yes, if you have a look on the chat, you will see the detail.
Yeah.
Okay.
Yeah.
And now the next one, we have the presentation of experimental investigation of the influence of a slope bottom of the behavior of inclined dense jets, which will be presented by
Xingyun. Good afternoon. Hi.
Okay. Hi. Now, yes, Xingyun Wang. Okay. Thank you, Xingyun. It's your time for presentation. Thank you very much.
Thank you so much. Good morning and good afternoon, everyone. I'm happy to be here. My name is Xingyun Wang, and I'm from University of Ottawa, Canada. My supervisor is Dr. Mohammadian, and I'm also collaborate with Dr. Ferrari. My research focus on the inclined dense jet discharge into the stationary water, specifically looking at how a slope bottom affects a jet mixing process. Before we dive into today's topic, let me quickly explain what an inclined dense jet is. It's a common method used in alpha system, especially in desalination plants. As you might know, the desalination is the process that transfers the seawater to the fresh water and to reduce the water scarcity. After desalination, the leftover, which is brine, it is a highly concentrated water, is usually discharged back into the ocean. So this discharge happens through a pipeline and a nozzle, which release the brine at an upward angle. Because it has some velocity, the jet travels upward before it eventually sinking back to the bottom. Since the brine is heavier than the surrounding waters, thinking of it like throwing a tennis ball, it forms a curved path like a parabola. Similarly, the jet follows this path while mixing with the surrounding water to dilute its concentration. So when designing alpha system, the goal is to maximize mixing along the jet path while to minimize the negative impact at the point where the jet hits the bottom. Most of the studies have focusing on the discharge angles, but my research take a closer look at the bottom surface. Since the jet eventually will interact with the bottom, so I'm going to study how the mixing change when the bottom is its slope. I conducted my experiment at the University of Cagliari in Italy using the laser-induced fluorescence technology to measure concentration fields. The setup is shown in the figure 1 and includes a large tank filled with the tap water and a brine tank that maintains the constant head. The brine is made using the tap water and the salt. It has the density is measured with a densimeter. Inside of the tank, we placed a blackboard that to simulate the slope bottom, and the angle can be adjusted manually. For this study, I tested slope angle from 0, 1, 3, and 5 degree, and the discharge angle of the nozzle is 30, 45, and 60. These are the 3 common discharge angle for the study of inclined dense jet. A laser was positioned at the side of the tank and to create a light sheet aligned with the jet center, the center of the jet. I measure the data in 2 ways. One is the laser sheet is parallel to the slope bottom, and placed a camera 2 meters above the tank to capture some concentration profile at different heights. And for the vertical section, put the laser sheet aligned with the center line of the jet, and the camera capture its vertical concentration distribution. So today I'm just focusing on the result from the vertical section. After processing the data, I analyzed the jet geometrical information and how it's diluted over time. The result shows that the impact point is where the jet hits the bottom is farther away on the slope bottom compared to the horizontal one. This makes sense because the slope bottom provides a longer travel path, or in other words, it's a longer trajectory of the jet. I also found that for the same slope bottom, the discharge angle for the 30 and 45 resulted in a longer impact point compared to the 60. So using this data, I developed a linear fitting function to present the relationship between the slope and the 3 discharge angle. And another key found is that the brine accumulation near the impact point. On the slope bottom, this accumulation of the brine is more noticeable on the horizontal ones, which leads that a higher brine concentration in that area. So ideally, as the jet moves through the water, the mixing should be like gradually lower the concentration. When the slope bottom gives a jet a longer travel path, which theoretically should improve mixing. But the interaction between the jet and the bottom actually causes brine that to standing there will pile up at the impact point, increasing the local concentration. So this is something that we need to pay attention because it could pose a serious risk to the marine life nearby. When the jet hits the bottom, because the flow would spread out in all directions. On the horizontal bottom, this spreading happens more freely. It can flow like all directions. And the brine will, but on the slope bottom, the brine will naturally flow downwards due to the gravity. And which will push upstream flow will moving backward, like to the downwards. And this interaction creates a more complicated flow patterns near the impact point, making the brine communication higher and there is less dilution. So because of this, the dilution of the brine accumulation near the impact point could have significant long-term environment impacts, especially on the slope bottom. So this research would provide important insights for designing outflow system when the receiving bottom isn't flat. And even if it is flat, we also need to focusing on the brine accumulation. So it highlights the needs to address the brine buildup and its potential harm to the marine ecosystem. And thank you for your time. I'm looking forward to your question.
Thank you, Jen. I think you present a very interesting experimental model. And have you implemented it in any numerical model of this sort of jets?
Yes, I'm using like the open form to simulate the jet on the slope bottom. I'm using before that I'm using Rance model, like the two equation, just a realizable epsilon model, but that one cannot show the result of the brine accumulation. So after that I'm using the large ideal simulation. So in the last year in this conference, I present the result from the large ideal simulation. And we can see the brine accumulation near the bottom. But interestingly is that from the large ideal simulation, we can see that the slope is actually increased mixing. But from my experiments, it shows the opposite way. So I found this is very interesting. So for now on, I'm building another large ideal simulation model to try to find out like the more accurate result, because I should rely on the experimental result more and using experimental validate
the model predicts the prediction is good with the one which you have in your experiments.
For the large ideal simulation, I compare the jet trajectory, like for the terminal rise height, where the jet reaches the highest point, and also the location of the impact point. So only from the geometrical information, the large ideal simulation shows a good agreement with experiments, but only the dilution part. And I think this is a common issue when simulate the dilution or the mixing creature for the inclined dense jet. So I'm still trying to maybe find a better model to predict the dilution information using the large ideal simulation.
Okay. So does anybody has any questions for Hyun-Jun? No. So now we open a time in some minutes in which, if you want, you can make your questions to any of the presenters. If maybe you have any questions for any topic that we had previously. Do you have any general question or any question for someone? No? Could you be so kind to connect your cameras? It is very nice to see so many young people together with Eva and Jose Maria, who also are young people. Well, if there is no questions, I want to congratulate to all you that you have made very good presentations, limited with the time we gave you, which is a short time, and you have to make a very big effort in resuming and making questions to others. And so I really want to congratulate you and encourage you to make presentations in future Congress in person. No problem, you are the best men and women of the future. So please do not hesitate in taking yourself very self-confident to make presentations, because your English, your exposition, your ways are very good for communication. So please don't feel ashamed in any moment in the future, because you really can do it. So we are more than happy to promote you in this sort of actions, just to encourage you for the future.
Thank you.
Okay.
Thank you so much.
So, Jose Maria, Eva?
Thank you very much, everyone who presented in this session, and also thank you so much, Amparo, for chairing this session and mentoring this group. The next session will start in about 15 minutes, so I hope to see you all there.
Okay.
Thank you very much.
Thank you.
Thank you, madam. Thank you.
Thank you so much.
Thank you.
Thank you very much.
Thank you. Have a good coffee break.
Hello, Professor Juhiha.
Hi, I'm Majat.
How are you? Can
Yes,
you
good.
hear me well?
Yeah, I can hear you good.
Hello, Jose. How are you?
Hello, good to see you.
Thank you.
Doing
So
yourself.
today, thank you. So today, I think Professor Xi and I are chairing the session. So Professor Xi, if you would like, I can introduce the first 6 presenter, and then you can introduce the next 6 presenters. Is that fine with you?
Yeah, sure. I think we have 13, right, in total.
13. Okay, so I will present the first 6, and you can present the rest.
Sure.
So it's 8 o'clock, and I guess we can start 8 o'clock in Canada, I would say, 2 p.m. in Europe. So our first presentation is about surrogate-based sequential approximation for sensitivity analysis of the AMR's equipped multi-phase CFD model, to be presented by Falcon Khalifa Al-Hussein. The floor is yours.
Okay, thank you. Good evening, everyone. My name is Fulkan Kafla Al Hussein, and I'm from Republic of Indonesia Defense University. Today, I'm presenting our study titled Surrogate-Based Sequential Approximation for Sensitivity Analysis of the AMR-equipped multi-phase CFD model. This work is a collaborative effort between the National Research and Innovation Agency (BRIN) and the Republic of Indonesia Defense University. Our study addressed a critical challenge in simulating subaerial landslide-induced wave phenomena using computational fluid dynamics (CFD). The multi-phase CFD model incorporates fluid and sediment phase. It's governed by mass and momentum balance equation. The phases are decoupled using interface momentum exchange closures and compute within the Eulerian framework. A two-phase key epsilon turbulence model is applied with closure to account for flow turbulence. Sediment particle interaction are modeled using a rheology-based particle stress approach. Using the Favre average Navier-Stokes equation for fluid and sediment phase interaction within continuum immiscible medium using Eulerian coupling has been modeled by Li and Huang 2021. The original model was further advanced by Tofani and Latifa 2025, who integrate the adaptive mesh refinement AMR feature from Rettenmeier 2019 in this model and test the AMR parameter with limited sensitivity analysis on serial implementation. These advancements, I can say, is the first time done and has been proven can dynamically adjust mesh resolution in area of interest and achieving a balance between computational efficiency and accuracy. However, tuning IMR parameters for optimal performance in this case remain a time-intensive process, which the study aimed to improve. So, the study aimed to simplify the sensitivity analysis process using optimal parameters, the resulting accuracy of the simulation output, and computational efficiency. We implemented a surrogate-based sequential approximation, or SAO, to optimize IMR parameters effectively to the model to reduce computational time of that model. This method combines sensitivity analysis with surrogate model, which acts as a simplified representation of the system, enabling faster evaluation. Surrogate model works by modeling the accuracy and computational time according to the changing of AMR parameters, driven by data from sensitivity analysis. The parameters used are sediment criteria, water criteria, refined interval, buffer layer, and N layer with 5 different levels. The key finding of this research is first, efficiency gains. Optimization of IMR parameters reduce computational time by up to 56% compared to the best case, while the process only needs 188 hours in total 10 sample used and can be fewer according to the number of sample used and according to the case. Secondly, accuracy improvement. Wave time series and landslide profile accuracies improved by 6% compared to the best case. As you can see in the poster, the landslide and water profile can capture the detail of real experiment profile. Consistency and simplification. Surrogate model results were consistent with conventional sensitivity analysis, but offered a faster and simpler alternative for parameter tuning. And for the real application, the surrogate model can also be used by fewer data, so the process also can be fewer. The conclusion, the study demonstrates that the significant potential of surrogate models in optimizing IAHR-equipped CFD model simulation, while our approach improves both computational efficiency and accuracy. Further, the evaluations are needed to explore IAHR performance in parallel computing environment. We believe this work contributes to advancing efficient and precise modeling in geophysical fluid dynamics. Last, I would like to thank my collaborators, the Research Center of Computing at BRIN, Mr. Novan Tovani, and Mathematics Department at Republic of Indonesia Defense University, Mr. Neldi Rezekinda Tarigan. Thank you for your attention, and I welcome any question.
Thank you, Volkan. The floor is open for any questions. I have a quick question. Why did you prefer to use the standard K epsilon model? Because it is commonly believed that realizable K epsilon is more accurate and it has the same computational cost, almost the same computational cost.
Okay, I consider to use two-phase K epsilon turbulent model because it closer to account the flow turbulence and can capture the interaction between particles. So the interaction between particles are considered with this two-phase K epsilon turbulence, and also the interaction of particle and fluid also considered in this governed equation. I think that.
Thank you very much. Are there any other questions?
May I have one question?
Sure.
Yeah, it's a very nice presentation. I'm just wondering, for your AMR approach, use depth mesh refinements. Have you think about any other, let's say, the fully adaptive unstructured mesh, or fully? I'm just wondering what's your software you use. It's based on your uniform mesh, or is fully unstructured mesh, or something like that?
Yes. So the application I use is OpenFOAM, and it's the mesh is like not fully unstructured. There's some part unstructured mesh in the slope, but the other is structured mesh.
Thank you very much.
So the unstructured mesh is unrefined. That's.
Thank you very much. I was informed that we will keep the questions for the end of the presentations and for the coffee break time. So we will have presentations one after another, and then at the end we will have the question and answer period. So our second presentation is about simulation of floating particles in the Gulf of Patras and Cornet system in Greece, to be presented by Alexandra Aspiotti. The floor is yours, Alexandra.
Thank you. Hello, everyone, and thank you so much for this opportunity. My name is Alexandra Aspiotti, and I'm going to present to you our study about the simulation of floating particles in the Gulfs of Patras and Corinth system in Greece. For this numerical experiment, floating particles were considered spread all over the Gulf system, as we can see in Figure 1. The simulation took place for 1 year, and barotropic conditions were considered. The movement of the particles was studied exclusively under the action of the tide. At the open boundaries, time series of tidal elevation constructed by astronomical constituents were used, and the area was divided in 6 zones in order to track the particles. The particles were released once and simultaneously at the beginning of the simulation. As we can observe, comparing the figures 1 and 2, the particles move westerly of the system. In figure 2, we can see that the particles in the central and eastern part of the Gulf of Corinth do not move due to weak tidal flow and complex topography. The particles there seem to be trapped while those in the western part of the Gulf of Corinth move towards the Rio Andirio Strait because of the presence of slightly stronger tidal currents in that area. After 6 months, we can see that all the particles initially released in the Rio Andirio leave that area and move towards the Gulf of Patras that seems to receive the floating particles from the eastern part of the whole system. As we can observe, the particles located in the northern part of the Gulf of Patras leave that area earlier, comparing to the south, where we have a high accumulation of particles. From this study, we can conclude that the replenishment excuse me, of the system is achieved via the Gulf of Patras towards the open Ionian Sea. The strong currents in Rio Andirio Strait move the floating particles rapidly to the exit of the system, while the tidal flow does not have an impact on the particles in the central and eastern part of the Gulf of Corinth. Thank you so much, and I am at your disposal for any further questions, but as you already mentioned, this will take place at the coffee break.
Thank you very much, Alexandra. Yes, so we will have all questions at the end at the coffee break. So our next presentation will be delivered by Reza Arefi, and it's about the impact of a canal on reduction of tsunami force in tsunami events. So Reza, the floor is yours.
Hello, everyone. Thank you so much. First, I wanted to know, is it possible to share my screen because I prepared a PowerPoint? If it's possible, I can share my screen and talk about.
There is a green button down at the bottom.
Yes, I am.
Share. Can you try that? Yes, it works.
Okay, thank you so much. Hello, everyone, again. The topic of my research is reduction of tsunami-induced forces on a structure using a rectangular mitigation canal is an experimental study. First, I want to talk about research needs and novelty. Tsunami exerted significantly destructive impacts on coastal infrastructure and caused the deaths of many people over the past few decades. To reduce the tsunami-induced effects on coastal infrastructures, various design provisions and planning zoning measures have been introduced. Unfortunately, there is only limited research on tsunami mitigation.
I'm sorry to interrupt you. Do you hear me? I think it's very nice that you prepare a presentation, but it's not fair towards the others that put effort into preparing the poster and presenting that. Because with the presentation, you have the choice to present much more.
Okay.
So I'm sorry to interrupt you after you started, but I think it's for everyone, it's better if we treat everyone the same way and we just share your poster as it was done for the others. I'm sorry to also step on top of the chairs, but like, I think it would be better for everyone to have the same format presented, because otherwise we could have allowed everyone to present their own presentation.
Okay.
Thank you. So I'm sharing your poster in like 2 seconds. Just give me the time.
Okay, thank you.
Yes, thanks, Arena. And once I'd like to remind, because I think we have a certain posters in this section, so probably everyone should keep within 5 minutes in order we can finish in 1 hour, and then we have a coffee break like afterwards. Okay, thanks.
I agree. Do you see the poster now?
No, unfortunately, just a moment. Yeah.
Okay, we'll try again. There is some lag time. You see that?
I cannot.
I can see.
Yes, no.
Okay. I talk about the methodology. Then here I wanted to say that to study the effects of canal, we perform a series of experimental tests in the laboratory in University of Ottawa, Canada, which here you can see the dimensions, the location of canal and column at the end of the flume. And we use a dam break method to generate tsunami bore and study the interaction of tsunami bore with water-filled canal, and after that with column. As you can see here on the graphs, there are you can see the time histories of horizontal force exerted on column for different widths of canal, 60 centimeters, 160 meter, and 3 meter, which the black one is related to the test with no canal, with absence of canal. And as it can be seen, the maximum of horizontal force is reducing by increasing the dimension of canal width. And as a conclusion, this study assesses the impact of mitigation canals on reducing tsunami bore energy and the resulting forces on downstream columns. Testing water-filled rectangular canals with various depths and widths revealed that these canals effectively dissipated tsunami bore energy and reduced flow velocity. Consequently, they significantly lower the horizontal forces exerted on coastal structures. And the findings indicate that wider and deeper canals are more effective in force reduction, with the largest canal reducing peak horizontal force by 25%. Of course, it should be noted that this 25% is related to our experimental test, which the canal dimensions is limited, but it seems for wider or deeper canal, it can be more than 25%. Thank you so much. If there is any question, I'm here. Thank you.
Thank you, Reza. So our next presentation is about port container throughput forecasting with univariate models, which will be delivered by Bavaria Miguel. So Bavaria, the floor is yours.
Well, thank you. Thank you for organizing this congress, as well for your assistance. So for having an optimal port planning and design, it's crucial to have an accurate forecasting of port container throughput, as any deviation in that or error in that state could lead into port congestion or an infrastructure underusage that may result in economic losses, as well as an environmental impact. So this research explored the application of three different models: ARIMA, artificial neural networks, and long short-term memory, on 4 different ports of the Spanish port system, as is Valencia, Algeciras, Bilbao, and Castellón. Those 4 ports has different transshipment rates. For example, Valencia has a mixed rate of transshipment as import-export, and for example, Algeciras has a transshipment rate of plus 90%, while Bilbao and Castellón are pure import-export ports. As well, those ports have different volumes, as Valencia and Algeciras are ports with a plus of 4 million TEUs on an annual basis, and Bilbao has approximately around 500,000, for example. The data period selected is from January 2005 to December 2019. And the models or the neural network models are applied considering both 5 and 10 months of previous data. And while the forecast horizon is fixed to 1 month, and its set of input plus output are considered as independent realization. As well, 2 different data sets are considered, one with the total throughput and the other one on considering an incremental monthly throughput. This approach is taking into consideration aiming to reduce the non-stationary component that may affect the forecasting. There in the poster is the formula how the incremental monthly throughput is calculated, and jumping into the conclusions for having an overall view of the models. The symmetrical mean average percentage is used, and it's or the best model is the artificial neural network, followed by long short-term memory, and the last one is ARIMA. And on the data approach, the predictions applying incremental monthly throughput had a better results than the total throughput data. Thank you, and I'm open to any question.
Thank you very much, Miguel. The next presentation will be about the Otis, the hurricane that exceeded all forecasts. So it will be presented by Rodolfo Ramirez, Continental. So Rodolfo, the floor is yours.
We have a change in the presenter, I'm sorry. It's Karina Ocaña that's presenting this poster. It was emailed a few minutes ago, sorry for that.
Okay.
So it's last okay.
Hi everyone. You listen me?
Yes.
Yes.
Thanks a lot. Hi everyone. Thanks a lot for this space. And we were presented to Otis, the hurricane that exceed at all forecasts. In this work, we concentrate in a numerical model that describe how the Otis hurricane, how the hurricane Otis, the consequence and the displacement in Acapulco Beach. Okay, well, sorry, but my English is not so good, but I try to explain. Okay, well, Huracán Otis appear from an atmospherical disturbance located a considerable distance south of the Guantepec Gulf. Initial projection indicate that it would be a tropical storm. However, Otis developed an inner core that took advantage of environmental and oceanic conditions to experience a rapid intensification. It strengthened at 19 knots in 21 hours, reaching maximum wind speeds of 145 knots and pressure of 929 millibars. In October 24, at 12 hours, Otis intensified to Category 1. By 18 hours, it had intensified Category 4, and in October 25, at more or less 12 hours, the hurricane made a landfall near to Acapulco port in maximum sustained wind of 145 knots, gusts of 178 knots, and displacement for 9 knots. For this work, we determined through numerical models the sea level rise by characteristics of the waves and currents that impact in Acapulco Beach by Huracán Otis. This model was calibrated with measurements provided by the National Tide Gauge Service operated by National Autonomous University of Mexico, the UNAM. And we determined with numerical model the storm surge and wave and current produced produced by Hurricane Otis. We use a numerical model spectral waves and flow models of the Mike 21. This software is developed by the IAHR. We use a force from the wind and pressure fields generated by this phenomenon. The information of the characteristic of the Hurricane Otis were taken for the HURDA-2 Hurricane Database second generation database. This was published by the National Hurricane Center. From the wind and pressure fields, we generate with the ranking vortex model. In the graphs, we show the peaks of the waves, currents, and sea level when the hurricane reached the peak when it made landfall, when the Otis made landfall. We find results with numerical model. The result were time series of the sea level rise due to storm surge, wide heights and current speed in Pie de la Cuesta Beach, Acapulco Bay, and Diamante Beach, where was for the three places difference. We estimate waves of 662 in Pie de la Cuesta, 662 meters in Pie de la Cuesta, in Acapulco Beach for 95 meters, and in Diamante Beach we found waves of 11.23 meters. The average sea level rise due to storm surge was 177 meters, and we regarding speeds of the currents of 31 meters over second in Pie de la Cuesta. In Acapulco Bay, we found currents of 26 meters over second, and in Diamante Beach, we found with this model or numerical model, we found speeds of currents of 45 meters over second. It's very important that we found with this model that according to the astronomical tide forecast, rising sea levels and low tide prevent the flow levels from the rising waters with an estimated rise of 39 meters above the mean upper high tide. In conclusion, we can see that hurricanes have a significant economic impact on maritime and land areas, and also technological advances that allow for the forecasting, tracking, and continuous monitoring that illustrate unpredictable phenomena that it causes losses and losses, economic losses. In this case, it's calculated more or less $5 billion, more or less, 5 deaths and many losses more, and lost human lives and very loss of human lives. In resume, Hurricane Otis is a clear example of the above, coupled with the effects of the climate change on the oceanographic condition that contribute to the fact that the forecast model did not anticipate its extremely rapid intensification, for this case in the Otis. Since the first results even indicate that the hurricane could be dissipated due to an expected increase in vertical wind shear. Is a very important conclusion, and the unexpected rapid intensification of the Hurricane Otis revealed that the challenges that models face in predicting the factors, warm sea surface temperatures, deep warm water, and high humidity and low vertical wind shear, that all these that contribute to the now recurrent rapid intensification of Hurricane Otis like these events. Thanks a lot. Very thanks a lot.
Thank you. Thank you very much, Karina. And our next presentation is about NARX model development for forecasting water level in Ashtamudi estuary in India. which will be delivered by Vidya Lashmi Nanda. So Vidya Lashmi, the floor is yours.
I see a co-author in the panel, so maybe we have a presenter that's not a first author. If so, can you please open your mic and introduce yourself?
So, good evening, everyone.
Good evening.
Go on, we hear you.
Am I visible, sir?
We can
So,
hear you.
good evening, I'm Aparna Devi here. Okay. Finally, a civil engineering student from TKM College of Engineering, Kerala, India. So today, I will be presenting our study on forecasting water levels in the Ashtamari estuary using NAAQS model. The Ashtamari estuary, located on the southwest coast of India, it is known for its rich biodiversity and economic significance. It supports thousands of fishing communities and serves as a crucial habitat for numerous species. The estuary experiences a unique microtidal mixed semi-diurnal tidal pattern influenced by freshwater input from the Kallada River and tidal variations from the Arabian Sea. So accurate water level prediction here is crucial for ecological management, navigation, and flood prevention. Our research focuses on using advanced predictive models to address these challenges in this dynamic and sensitive ecosystem. So to begin with, the data was collected from March to December 2023 at 2 water level sensors, which is located near the estuary mouth and 8 kilometers upstream. Additionally, river discharge data from the Kallada River was recorded. And using this data, the NAAQS model was applied in 2 approaches. The model 1 used historical water levels to predict future water levels. Then the model 2, which incorporated river discharge data for more accurate predictions under varying hydrological conditions. And the models were trained and validated using a systematic data set split of 70% for training and 15% each for validation and testing. Auto-correlation analysis was conducted to assess the predictive capability of the models. And for the result, model 1, which relies completely on historical water level data, it showed high autocorrelation at lag 6, which an R value of 0.9801 during testing. However, it does not account for external influences like river discharge. Model 2, which incorporates a river discharge as an additional input, exhibited improved performance, achieving an R value of 0.9826 during testing. This indicates that including river discharge helps capture the variability caused by hydrological changes more accurately. And the response plot in figure 2 illustrates the difference between the observed and predicted values for both models. As shown, model 2 provides predictions that align more closely with actual data, particularly during periods of fluctuating discharge conditions. Additionally, the test plots reveal that model 2 reduces prediction errors and captures the seasonal and tidal variations in water level more effectively. So to summarize, 2 predictive models were developed and both demonstrated high accuracy. The inclusion of river discharge data in model 2 highlighted its importance in improving forecast precision. Also, this study tells that the NAAQS model can serve as a reliable tool for water level prediction in estuaries with applications in resource management and ecological planning. Thank you.
Thank you very much. So our next, Professor Shi, the floor is yours.
Okay. Yeah, thank you, Professor Mohammed. So our next speaker is talking about the mass conservation analysis and the physics capture of wetting and drying treatments at moving boundary problems, presented by Abu Bakr. Yeah. So the speaker is here, so
hello.
the floor is yours.
Thank you very much. Thank you very much, moderator. Good afternoon, all. My name is Abdul Bakar. I'm from Department of Water and Environmental Engineering, Faculty of Civil Engineering, University Technology Malaysia. Okay, my presentation this afternoon will be about, as the title mentioned, the mass conservation analysis and physics capture at wetting and drying numerical treatments. The problem is at the moving boundary. Okay, this study is mainly about the finite element methods. It involves the shallow water equations, and definitely the problems and the solution will be the wetting and drying. Let me begin with introducing the study. This is about the 4 wetting and drying algorithm, which is based on an author, Medros and Hagen, in 2013 review, there are 4 algorithms involved. The first one, thin film algorithm, element removal algorithm, that extrapolation algorithm, and negative depth algorithm. There are another authors that conduct the study relates to this wetting and drying phenomena. Okay, this study is mainly aimed to analyze the physics capture of the shallow water equation, as well as the conservation of mass at wetting and drying numerical treatments, which is definitely like moving boundary problems. Okay, this study involves several materials and methods. The first one is about the shallow water equations. For example, equation 1 and equation 2 is the equation that will be solved, which is the continuity equation, the first one, and the second and third are the momentum equation in x and y direction. The methods involved in this study, there are 2. The first one will be the element removal algorithm, and the second one is the negative, which had been tested. Before the model or the study conducted or the simulation was run, so there will be analytical solution for water oscillation in a paraboloid bowl by Tucker 1981, which is used as a test case in this study. Additionally, this test case is used to test the mass conservation property as well. For example, equation 4 is utilized to observe how the conservation of mass change based on different wetting and drying scheme. Other than that, this Tucker test case is used to test the convergence of the proposed methods towards the analytical solution. Convergence study means that we refine, or me myself refine the mesh, which is the decreasing
Apple, so I'm not sure whether you are still there. We can't hear you. So I think the speaker probably is lost the connection. So it's mainly probably due to the time limits. I think probably we have to move on. So, and also I'd like to remind all the attendants and then the participants as well. So I can see a very active discussion in the Q&A section. So when you ask questions, please address to the presenters, so the name, and then after the presenter finish their presentations, actually they can respond to the Q&A section. So that's very good. I think in that case, we will probably discuss these posters in our break and then coffee break. And then next, probably have to move on to the next presentation. So which is for the idealized modeling of water columns in tidal inlets, error analysis of FEN based spatial digitalization, which is presented by Tian Qin. Yeah, Tian Qin, are you here? Yeah, floor is yours.
Okay, thank you, Professor Xie. Hello everyone. My name is Tian Qi, and I'm a doctoral student at the Department of Civil Engineering, Ghent University in Belgium. And today I'll present my research on idealized modeling of water motion in a rectangular tidal inlet, focusing on the finite element methods, spatial discretization, error analysis. And as we know, numerical modeling is indispensable for managing tidal inlet systems, especially at barrier-type coasts like those found in the Dutch Wadden Sea. While complex process-based models like Delta 3D and Telemark provide detailed simulations, they often come at a high computational cost. And idealized models offer a complementary approach. And these models schematize the geometry and prioritize critical physical processes, enabling efficient sensitivity analysis and gaining insights into system behavior. So building upon the work of Schutelaars et al., we developed an idealized 1D model of a rectangular tidal inlet with a fixed linearly sloped bed. This model is forced by the semi-diurnal lunar M2 tidal constituent at the seaward boundary. We employ a perturbation method to solve the 1D shallow water equations in the harmonic domain and use the finite element method for spatial discretization. Specifically, we first non-dimensionalize the shallow water equations by scaling the variables by their characteristic scales. We expand the solution in terms of a small parameter epsilon, which represents the ratio of the width averaged M2 tidal amplitude to the mean water depth at the seaward boundary. This allows us to decompose the dimensionless solution for the sea surface elevation zeta and the tidal velocity u into leading order and higher order terms. The leading order solution, which captures the dominant tidal dynamics, is the primary focus of our present analysis. So for spatial discretization, we adopted the finite element method, and this method offers flexibility in handling more complex planform geometries in our future research. We use a standard Galerkin formulation and employ polynomial basis functions through the Phoenix software tool to approximate the solution for the spatially varying components of the hydrodynamic variables in the harmonic domain. And to assess the accuracy and efficiency of our numerical models, we conducted an error analysis. We investigate the impact of two primary refinement strategies, namely H refinement, which refines the mesh by increasing the number of elements over the domain length, and P refinement, which increases the polynomial order of the basis functions in the elements, while keeping the number of elements constant. And we quantify the error using the L2 norm of the difference between the numerical solution and the reference solution. For the frictionless case, we use the analytical solution as the reference. And for the frictional case, we employ a highly accurate numerical solution obtained on a very fine mesh with the high order polynomial basis functions. Our numerical experiments reveal that P refinement is generally more efficient than H refinement in reducing the error. And by increasing the polynomial order, we can achieve significant improvements in accuracy without the need for excessive mesh refinement. And of course, to balance computational efficiency and accuracy, a judicious selection of mesh size and polynomial order is crucial. And for our future research will extend this analysis to higher order solutions in terms of the small parameter epsilon, as well as to more complex planforms than a rectangular tidal basin. So much for my presentation. Thank you.
Okay, great. Yeah, thanks, Tian, for your nice presentation. And then we will have discussion later on. Okay,
Thank you.
so due to time limits, we have to move on. So the next presentation is about development of a 3D hydrodynamic model for long-term analysis in the tropical microtidal Tensestari river estuary, which is presented by Kyosuke Hamada. Yeah. So if you can keep your presentation within 5 minutes, that would be great. Thank you.
Can you hear me?
Yeah, everything's good. Yeah, floor is yours.
Good afternoon, good evening, everyone. Thank you so much for giving me this opportunity. My name is Kyosuke Hamada from Tokyo Metropolitan University in Japan. The topic of my research is about development of a three-dimensional hydrodynamic model for long-term analysis in the tropical macrotidal Tanindali River estuary in Myanmar. For the introduction, the Tanindali River tropical macrotidal estuary plays a vital role in Myanmar's fisheries industry. However, saltwater intrusion significantly influences its water quality and marine ecosystems. Therefore, it is required to establish the effective model so that we can understand the estuarine hydrodynamics and promote fisheries industry in Myanmar efficiently. While most of numerical analysis for the estuarine has been done for a short-term period in previous studies, our study focused on developing a numerical model capable of simulating saltwater intrusion dynamics over an entire year, including wet season and dry season, utilizing available hydrological data. So for methodologies, I'd like to explain the site description and model setup. Our study site is located in the south part of Myanmar, as you can see in the figure number 1. Then it has the huge basin area, and aside from that, it has noticeable differences in terms of rainfall between wet season and dry season. Regarding model setup, we utilized the phantom refined, which is one of the three-dimensional hydrodynamic model. In that model, we incorporated freshwater discharge estimates derived from the tank model. Additionally, we also include tidal water level from the TPXO datasets and regional hydrological data. Then this model was finally calibrated and validated using salinity data we actually observed in Myanmar during both wet and dry seasons of 2019. Then, as a result, the tank model has proven effective in addressing tidal influences during dry seasons where traditional methods such as Manning's equation are less reliable. Regarding the results of the long-term three-dimensional simulation, here is a comparison of longitudinal distribution of salinity from the river mouth as I show in figure number 3. We found that the model accurately reproduced the longitudinal salinity distribution and salt wedge dynamics in both wet season and dry season. And based on the result of variation of saltwater intrusion lengths throughout the year of 2019, as shown in figure 4, number 4, it is demonstrated that seasonal variation were captured effectively with saltwater intrusion lengths showing an inverse relationship with the amount of freshwater discharge. For my research achievement, this approach not only enabled successful long-term simulation, but also demonstrated the practicality of long-term modeling for hindcasting, missing the data, and forecasting future scenarios, particularly in data-limited regions. And lastly, I'd like to express my gratitude to my co-authors and the organization supporting this research. That's all of my presentation. Thank you so much.
Okay, great. Yeah, thanks, Kansuki, for your very clear presentation, and also keep within time limits. Yeah, we will have a discussion later on. Okay, thanks. So next, we'll move on to the next presentation, which is about the buffer blocks as a wave energy dissipators, which is presented by Sas Vences Nagan, I think from IIT Madras.
Thank you, sir. Hello, everyone. I'm Sakti Vasant. I'm currently doing my PhD in Indian Institute of Technology, Madras. I'm from India. So I'm here to present my topic as buffer blocks as wave energy dissipator. So we know that extreme events like tsunami and storm surges can cause greater damage to the coastal livelihood as well as the infrastructure. So there are many strategies that were put forth in order to mitigate these extreme events. So some of the strategies like steering away, shifting will not work for a already developed area. So the only possibilities are blocking and also the slowing down. So blocking involves hard countermeasures such as seawalls, and they have their own demerits as well. They are also expensive to construct. So we are going in for buffer blocks, which are space saving as well as they are economically feasible. So today I'm going to discuss about the numerical simulation that were carried out based on these buffer blocks. So I'm computed several flow characteristics such as flow velocity and water surface elevation at the multiple points in the flow domain, and particularly in the 5 meters from the buffer blocks, I have mentioned I have computed the this flow velocity as well as the surface elevation. So based on this flow velocity and surface elevation, I have computed the momentum flux, which is a measure of force in absence of the structure. So so before going into buffer blocks, we have to see about the geometry of buffer blocks. So majorly these buffer blocks idea was borrowed from the stilling basin blocks that are present in the dam downstream side of the dam. They help to induce hydraulic jump, thereby reducing the flow velocity, as well as they create a lot of vortices, also reducing the flow velocity. So the height, width, length, and the spacings were based on the USBR type 9, which is nothing but the sailing basin block commonly employed in the downstream side of the dam. So the longitudinal spacing, that is the distance between the rows of the buffer block, was also established in Percy et al. 2006. So here I will be discussing on the following test cases. Initially, I went with varying the number of rows of buffer blocks, like from 1 to 5, and I examined their effectiveness. Later, there was I understood that the height was a major parameter that is deciding the effectiveness of buffer blocks. So I changed the height of the buffer block in alternate rows, as well as I arranged the buffer blocks in the increasing order of heights as well as the decreasing order of heights. So in order to check the results here, we need to understand the parameter called R, which is nothing but the free flow depth observed near the buffer block position divided by the height of the buffer block. This helps to signify the input characteristics of the domain. So here in the results, we have computed the momentum flux percentage reduction for all the 3 test cases. So initially, when we are checking out this number of rows of buffer blocks, beyond 3 rows, we observe that there is no further significant reduction. So I am adopting here 3 rows as constant, and my further computations were done with 3 rows as constant. So later, second is the block height variation, where H2 represents the height of the blocks in the second row, while H1 is the height of the blocks in the first row. So that was varied with from 0.8 to 1.5, and I can observe that the percentage reduction of momentum flux was linearly increasing while I have increased the H2 by H1 ratio. Then later, I observed this ascending and descending arrangement, where the descending arrangement supposedly gave the highest percentage of momentum flux reduction. So finally, I like to conclude that based on this computation, descending type seems to be the good one, and it was calculated against the real-time metrics like human height, average human height, and as well as the average human sprinting speed. And we were able to conclude some significant findings like that. For lower R values, this buffer block seems to be perfect and effective, but with increasing R values, the effect of buffer block seems to be negligible. So the future works will focus mostly on varying the shape as well as the as well as the spacings in between to check the efficiency of buffer block. So here I would like to thank my co-authors, K. Varadaraj, Professor V. Sriram, Professor V. Sundar, and Professor Chutrum for their guidance and support. And I will also like to thank the DFG, German Science Foundation, for their funding. And also, I'm from the IAHR South Indian YPN group, which is formed 2024. I'd like to represent them. So thank you, one and all, for the opportunity. Thank you.
Okay, great. Yeah, thanks for your nice talk and also some good simulations. So we'll discuss that later. Okay, so next we will move on to the next presentation. It's about the impacts of climate change on the reliability of reliable mount breakwaters, considering the correlation among design parameters, which present by Ali Jamali Rawashid.
Hello everyone, good afternoon. My name is Ali Jamali Rovesh and I'm master's student at Terbiat Madaris University, Iran. This research is a part of my master's thesis supervised by Professor Shafifa. In this study, we investigated the impact of climate change and correlation of environmental parameters on the reliability of rubble-mounted barren breakwaters. Our study addresses three main aspects: the probabilistic analysis of breakwater and their uncertainties, the correlation between the environmental parameters using cupola functions, the impact of sea level rise due to climate change on breakwater reliability. For this case study, we selected the breakwater at the Tombak port in Persian Gulf. We focus on overtopping, a key failure mechanism that is heavily influenced by climate change. In our approach, we used cupola functions to model the correlation between parameters. For this study, we employed the divine cupola structure to capture the dependencies between the significant wave height, wave period, and water level, as shown in figure 1. For the probabilistic analysis, we use the UQLab toolbox in MATLAB, applying for methods Monte Carlo, form, SORM, and importance sampling. Given the high accuracy of Monte Carlo method, we focus on its results here. The findings reveal varying failure probabilities depending on the relationship used for overtopping calculation. Moreover, the correlation between parameters significantly impacts the failure analysis, leading to overestimation and underestimation. It's depend to relationship again. These effects are demonstrated in figure 2. Previous studies on the impact of climate change in Persian Gulf predict a 36 centimeter rise sea level, which increase failure probabilities across all relationships. However, the extent of this increase varies between methods. This highlights the importance of selecting the appropriate relationship in the design of the probabilistic analysis of breakwaters for better decision making. Additionally, as shown in figure 3, neglecting the correlation between parameters leads to differences and reduced accuracy in the results. One key finding from our study in the EuroTop 2007 formula, which is less sensitive to parameter correlation and can be used without accounting for them. Our analysis show that accounting for correlation with divine cupola affected failure probabilities. The greatest difference between correlated and independent parameters was found in Sigurdarsson and Vandermeer 2012, a formula with 3.16% difference. On the other hand, EuroTop 2007 showed the smallest difference at just 0.05%, with a 36 centimeter sea level rise. Failure probability increased by up to 6.4% for EuroTop 2007 model and only 0.42% for the Sigurdarsson and Vandermeer 2016 model. These results underscore the critical importance of considering both parameter correlation and sea level rise in the assessing breakwater failure probabilities. And this study has important operational implications. Ignoring the correlation between environmental parameters can lead to inaccurate failure probabilities, affecting breakwater design. By considering this correlation, engineers can optimize design, ensuring more reliable and cost-effective coastal protection solution. This approach helps in better resource allocation and enhance infrastructure resilience in the response to climate change. Thanks for your attention.
Okay, great. Yeah, thanks, Ali. Yeah, for your nice explanation. I think now, just from the organizer, I know there's the next two speakers actually, unfortunately, will be not here. So it's mainly we actually exactly on time on our schedule. But now I would like to probably let Amirahu probably he left. I think outlines probably give you 1 or 2 minutes to finish your poster. Or
yes, sure.
Yeah. So if I just want Angelina, if you can bring Amiraho's poster, so we can give 1 or 2 minutes for him to explain a little bit further, please.
Can you remind me the name of the first author, because I ordered them in that way?
It's about a mass conservation analysis of the physics. So I think is
like this one. I have it. Give me a second.
Yeah. I think because we have a little bit time, so probably let him to finish that poster. Yeah,
this one, right?
Yeah, that's right. Yeah.
Good. Right.
Okay, so Amirahu, so the floor is yours. If you can short, maybe 2 or 3 minutes, that'd be great. Thank you. Amirahu, yeah, you can start when you're ready.
Yes, thank you very much for the opportunity. Let me finish this. So basically, based on these two figures, I will say that the method of characteristic had been used for the wetting and drying scheme. So there are option for the treatment of tidal flats, which is number 1, tidal flat detected, free surface gradient corrected. There will be another tidal flat area removed, and then detect porosity terms added to the half dry element as well. But based on these results, generally method of characteristic did not perform as compared to the second one, which is the edge by edge implementation of the N distributive scheme. So when I switch from method of characteristic to N distributive scheme, so the physics captured to the analytical solutions. But then when I apply the method of characteristic, for example, there are lots of options that I tried. So the results present in different ways. But then we can observe that on the left side, the wiggles actually happen at the wetting front, by the way, and then the velocity also fluctuates in different ways when I apply different scheme of the wetting and drying. So in conclusion, the method of characteristic and edge by edge implementation and distributive scheme, these are two finite element based advection scheme that had been implemented with the wetting and drying numerical treatments of the another two algorithm, which is element removal algorithm and negative algorithm, which is for the improvement of physics capture, and then as well as the mass conservation at the moving boundary problems. Well, thank you very much for the opportunity.
Okay, thank you. Okay, that's great. I think within that, I would like to thank you all the presenters, I think, for the presentation. So everyone keep very professional and then keep time. I think it's very good. So now actually we have time, so we're moving to our coffee break with mentors. So I would like to pass back to Professor Muhammadin, probably to chair the coffee section. And then I would like to remind every presenters, if you can switch on your cameras, and then probably we can start to have the Q&A section. And then anyone, if you can ask the questions or type in the chats. Yeah, both ways is fine.
Thank you very much, Professor Shi. So let's start on questions and answers. So the first question is by Professor Dr. Sanik. Dr. Sanik, would you like to ask your question? Are you here? So let's move on to the second question by Professor Ahmed. The floor is yours, Professor Ahmed. So Professor Ahmed is not here. And the third question is by Trika. Would you like to ask your question?
Hi.
Hi,
I
go
think
ahead,
that it is for us. This question is by Trika Agnestania. Okay. She asked that how do you represent the sea level rise during a storm event based on wave model result using Mike 21? And the second question is what method is used to analyze the sea level rise data? Well, we use the wind fields for and pressure for the analysis the sea level rise data for the Hurricane Otis, and we use an accoupled model with wave and with hydrodynamic model. We accoupled the three things, and this is the way that we model Hurricane Otis with an increase of level rise. Thanks a lot.
Thank you.
I don't know if I don't know if there is another question, but for the Otis hurricane is the answer.
Yeah, that's great. I think Professor Mohammadin, I think probably the attendee cannot ask the question because they are they cannot raise, I think, the unmute. So probably we just read the questions on, and then the presenters can answer the question.
Okay, so go ahead, please.
Yeah, I think the next one is by Dr. Senik, asked the Riza Afrafi. So the question is about what dimension of wider and deeper canals that are more effective in force reduction. Are additional dampen structures installed in this canal, such as buffer rocks or wave breakers? In what way do they reduce energy due to the backflow and hydraulic jump that occur? By what percentage the flow velocity can be reduced? Thank you.
Thank you so much. We measured bore depths at different locations, and as well as the force exerted on column by installing a load cell on top of the column. And at this stage, we didn't measure the velocity. For the next stage, we will measure the velocity as well. But here we have bore velocity at different locations, as well as horizontal force exerted on the column, and a time series of horizontal force.
Okay, great. Yeah, I hope that answer those questions. And I have one question for you. Actually, is mainly when you measure the force, is mainly do you measure both the horizontal and then the lift vertical force as well, or you just measure the horizontal drag?
Yes, the load cell measures it's a 6-axis load cell, but we just needed the horizontal force, not the other forces at different axes and directions.
Okay, great. Yeah, thank you. Yeah, so Professor Mohammed, you can probably speak out the next question, I think.
Yes. So I asked the question by Professor Ahmed. Waves are relatively high. What is the water depth where these values were observed? Juhi, how would you like to answer this question?
I think that's related to the presentation by Karina, right?
Hi. Yes. Well, we use a tidal observer from UNAM. The model was calibrated with a measure of tidal UNAM and with the base date the Hurricane Center, the Hurricane second generation, and for forecasting or forecasting values, we accumulate this value, and with this date, it were calibrated model. It was calibrated model, sorry. But yes, we have in Mexican Transport Institute, we have a void oceanographic, but in this moment, the connection and communication is lost, and then we use the other database one with wind and with pressure. We use two dates for that.
Thank you, Dr. Sheep.
Okay. Yeah, I think it's mainly. I think I will. I think the question from the Dr. Sonic. So it's mainly regarding us for the FUCAN. So FUCAN Ali. So it's mainly the question. I think is our first presentation. What is the relationship between the wave time series and the landslide profile on computational time up? If the profile is up more than 6%, does the computational time up decrease or increase? Does this analyzed models correlated with the hazard classification for land type that are likely to experience a landslide? Can this model be applied to cases such as liquefaction in the cities of Peru? Thank you.
Okay, let me answer. So, the landslide profile F and wave time series is one of the metrics evaluation. So we have three metric evaluation: wave time series accuracy, landslide profile accuracy, and computational time. We don't measure relation between it. We just measure relation between the IMR parameters and those metric evaluation. So the increase 6% of landslide profile prove that IMR parameters, the optimal IMR parameters is increase the accuracy both with the computational efficiency. That's it, I think.
Okay, great. Yeah, thank you for your question.
Thank you. I have a question for Miguel about ANN method. Could you please explain what were the input parameters for ANN? How many previous time steps did you use for your simulation? Thank you.
Yeah, so thank you for your question. So in this study, the number of parameters has been very controlled, and both for ANN and as well for LSTM. And basically, the number of parameters should not be more than the actual number of data. So we have like 168 parameters.
Thank you, Professor Shi.
Yeah, I think probably we try to answer all the question in Q&A, but now I think I have some question with Amira Hu. So Amira Hu says mainly you present, I think, the finite element model for the shallow water equation, focus on the moving boundary problems. And I was wondering why you want to focus on the finite element methods rather than other, let's say, finite volume or finite difference methods.
Well, thank you very much for the question. That's an interesting question. It relates to the finite element. So basically, the model that I used to simulate the process of wetting and drying at moving boundary is using open source Telemac. By the way, this is 2D model domain. So Telemac is come with the main equation, which is the solution using the finite element. So there are several methods that have been developed for the finite element. Besides that, they have the finite volume as well. So at this moment, what the methods that I use to try or to simulate is using the method of characteristic as another methods using the finite element. So basically, besides this study, so I try to use the finite volume as Telemac has finite volume. They are producing results, but then I'm going to do the analysis in terms of what we call the physics capture in terms of the free surface as well as the velocity profiles. On top of that, what we call the conservation of mass, conservation of momentum also need to be tested using different scheme, especially for based on the finite volume as well. That will be the next step of the study.
Okay, great. Yeah, thanks. Yeah, looking forward to hear your new results. Thank you.
Thank you, Professor Shi. I have a question for Alexandra. I would like to know which equations you used for particle tracking. Was it a dynamic particle tracking based on Newton's second law of motion, or it was a kinematic simplified particle tracking? So it looks like Alexandra is not available. So maybe I can ask my next question from Vidya Lashmi. So you used 15% for validation, 15% for testing, and 70% for training. Typically, validation and is separate, and training and testing are within the same group. Why did you make a separate analysis for testing and validation? And is 15% enough? Is just 15% enough for validation? Thank you.
So actually, when we referred most of the papers and all, 70% for training and 15 for testing, and for validation was the thing that we have used. So I think validation and testing both are different, because first we will be training the model with some of the data, and after that we will be testing, then validating. It's so that it makes the model more accurate.
Thank you. Are there any other questions?
Yeah, I have, Professor Mahmoodian. Yeah, thanks for you. So I have, I think I have some follow-up question, I think, regarding finite elements. I think that's with Tian. So I think Tian, you developed a one-dimensional, I think, finite element method for the shallow water equation. I was wondering whether do you have any plan to extend for the two-dimensional, and then what is the challenge to doing that?
Yeah, we do have the plan to extend the model to 2D. It would be a 2DH. So it's just a depth averaged model, and the challenge, of course, would be the more complex geometry. And So not just for rectangular basins, and we have also studied the exponentially convergent and divergent basins. And also more realistically schematized inlet geometry, but we find it a bit difficult for the boundary problems, especially in the shallow water part where the water depth is going to diminish. Yes, and so in the shallow regions, there are always some numerical problems that we have to find a way to circumvent.
Okay, good. Yeah, thank you for your answer. Yeah, hope
Thank
you
you.
can deal with that soon. So,
Thank you. Can I
yeah,
ask
thank
a
you.
question from Abu Bakr, please? Abu Bakr, how did you integrate the bed slope term, and how did you make the method of characteristic mass conservative? Because method of characteristics is not mass conservative in general. Thank you.
Well, thank you very much for the question, Professor. Yes, I begin the test case with the method of characteristic. This is because I have a previous study where I apply the finite element using several methods or algorithm based on wetting and drying. So we observe, or me myself observe the deviation in terms of the conservation of mass. That's the reason I scale down the study into this parabolic moving boundary in the parabolic bowl, in order for me to see what is actually happen when I apply the method of characteristic compare with the other schemes in finite element. For example, I have here this is n distributive scheme, and another one will be p distributive scheme. Besides the other approach, which is finite volume as well, is available or comparable that could be used. So that's the reason why I begin my test case using the finite method of characteristic based on the finite element.
Thank you, Professor Shi.
Yeah, can I have one question for the Kyosuke, please? So you mentioned the three-dimensional hydrodynamic model, so which is I'm not sure whether it's an in-house development or some other model. Can you explain a little bit more about the 3D model you used? Thank you.
Yes, thank you for your question. I utilized the phantom refine, which is one of the three-dimensional hydrodynamic model. Then this model was developed by the one professor in my university. Then phantom refine is mainly composed of like continuity equation and Navier-Stokes equation with like a structured grids. Then the advantage of use of phantom refine is there is no like a well-established GUI comparing with other like model. So we can easily like edit, we can easily adjust whatever we want. This is I think this is advantage of use of it.
Okay, great. Yeah, thank you.
Thank
Yeah,
you. I have a quick question for Ali Jamali. How did you calculate failure probability? Can you elaborate on that, please?
Yes, thank you about this question. The failure probability calculated in the UQ lab, as I mentioned, and in the UQ lab, we changed some limited state functions of our based on our overtopping formulas. And after that, it automatically calculate based on the Monte Carlo methods and give us the probability and probability failure of this function.
Thank you, Professor Shi.
Yeah, thank you, Professor Mohammed. So I think I have a final question for the Sakis and Vasasi and Nahan from IIT Madras. So it's mainly you actually simulate a lot of block and then different heights. And I just wondering whether you validate your model for just like say the flow of a single block to compare with the surface elevation and then the force acting on a single block.
Sir, can you please repeat? I couldn't follow.
Yeah, so it's mainly in your presentation, you show some simulation, right, to simulate a various array of blocks. So I just wondering whether you validate your model just for a single block, so or single cuboid, to compare the force acting on the cuboid and some free surface elevation as well.
Actually, I validated using other experiment called a Fleissman experiment, where a dam break flow, a single obstacle is placed, and the pressures and also the water elevation, those characters I validated and has been presented in the paper. But as you said, for this particular presentation, I haven't shown these forces, and I have only just shown you the surface elevation, velocity, and momentum flux, which is the product of both the surface elevation and velocity.
Okay, great. Yeah, thank you.
Thank you, Professor Shi. I have one question, another question for Tayal. I would like to know if your equations are mass conservative or not. Okay. So we will move on to the next question for Vidya Lashmi. Isn't it expected that the model with discharge and water level as input is always better than a model with just one of the two parameters? Okay, so are there any further questions? Okay, so if there are no further questions, this closes our session. Thank you very much, everyone, for attending this presentation. Thank you very much, Professor Shi, for helping with the moderating this session. Thank you, everyone.
Yeah. Yeah, thank you. I would like to thank all the presenters as well. And also I would like to thank actually our background, which is Arena and then Josie's, and then which help us to, I think, share the screen for your poster, and then everything went smoothly. And I also thank Professor Mohammedan for chairing this section and with me. And I hope you enjoy this section, which is for coastal and the marine hydraulics, and then also the marine outflow systems. And then hope you will enjoy, have a little bit 3 minutes break, and then enjoy the next section. Thank you.
Thank you, sir. Thank you.
Thank you.
Thank
Thank you
you.
very much.
Thanks a lot.
So the next session is groundwater hydraulics and measurements. So please, all presenters, raise your hands to ease our job. And we have 3 minutes of coffee. So go and grab a cup.
So if you're a presenter in this session, you need to be upgraded to a panelist, so please raise your hand.
And just a question for the sharing of the posters, who will be in charge to share
I will
it?
share the posters.
Okay, great. Thank you.
Yeah. So I think we can start with this session. Welcome to the groundwater session, and a very warm welcome to our chairs and mentors, Lucia and Paolo, who will be chairing this session.
Thank you so much. Dear authors, mentors, and attendees, it is my honor to welcome you all to the session called Groundwater Hydraulics and Management. And as the representative of the UNESCO Groundwater Youth Network, organizers led me to share with you some information about our network. So we are a pretty young network. But in the 2.5 years that we are functioning, we participated in a high-level events like UN Water Summit, UN Water Conference, 10th World Water Forum at Bali this year, IAHR Groundwater Congress at Davos. We are a big network, pretty big network, because we have global members from a lot of countries. And we actually managed to do in 2.5 years, we managed to produce Youth Declaration on Groundwater. And if you want to learn more about our network, about our aims, our goals, just look us up at the social networks, and you can see that we participated in many conferences as moderators, as co-organizations, or as authors. So it is time to start the session. And I would like to ask first authors of the first abstract, assessment of groundwater potential zones using remote sensing, GIS, and AHP techniques in the Nigris district, Tamil Nadu. So authors Akantasha Taigi, Vaikas Kumar, floor is yours.
Good evening, everyone. Please, can you present my poster, or should I have to present?
The poster will be presented. Just a second, please.
Oh, thank you. Shall I start?
Yes, you have 6 minutes.
Good evening, everyone. My name is Vikas Kumar Maurya. I am doing my PhD from Indian Institute of Remote Sensing as a collaborator, and my main host is IIT Bombay. And today, as a main scarcity in the groundwater as a topic, we found in the southern part of India. I have taken the modern technique to delineate groundwater potential zone in the Nilgiri district. For objectify my this research work, I have taken 6 parameters, that is the geology, geomorphology, lineament, density, drainage density, slope, and rainfall. For giving the for these parameter, I am using to collecting these parameter data from the remote sensing technique, then integrate with the GIS, geographical information system tools, for integrating both the technique, and then after using the multi-criteria decision-making technique that is called AHP, basically based on the pairwise matrix correlation factors with all the correlating parameters. So that will be give the normalized weight of the each parameter that will give the particular factor as a priority rank. That rank will be assigned to the each factors, like for the geology, geomorphology, these two parameter has given the highest rank, because in this Nilgiri district the geology is very rugged, because they are geologically controlled. Their rock type is charnocite, or mostly metamorphosed rock are available. And in the geomorphology part, we can see that there is a highly dissected hills are there, and in the southern part of the Nilgiri district there is a planar region, but most of the Nilgiri districts are controlled by the hilly terrain. So these hilly terrains not allowed to recharge the groundwater. And the other parameters like lineament density, and these are the lineament density and drainage density. These are the structural control factor of the surface. These parameters are basically prominent for groundwater infiltration and recharge. So if there is any lineament density is high, so there will be a chance to get a groundwater potential zone more. And if we talk about the slope, that slope data has been taken from the SRTM DEM 30-meter spatial resolution, that is taken from the remote sensing technique. And the data has been taken from the for the preparation of lineament and drainage density, that will be taken from the Landsat 8 data. We have to digitize all the lineaments manually. Then after, we can use the GIS tool to interpolate in all the geospatial region. Then after, if we talk about the geology and geomorphology, geology has been taken by the Geological Survey of India. The shapefile of all the geological features like the geological lithology like charnocite and other metamorphic rock has been digitized by the QGIS software. And if we talk about the geomorphology has been demarcated by the using Landsat 8 data. All the features like dissected hills region and pediments and other water body, all these are digitized by the Landsat 8 data. If we talk about the rainfall is also play a crucial role in the groundwater recharge, where the high rainfall, the map is classified into the 5 different rainfall category, where the region which is very significant to the rainfall, that will be more groundwater potential. There will be a chance of getting more groundwater potential. Now we can come to the pairwise matrix comparison. I have assigned the weight for each parameter, and according to that parameters, there is a geomorphology, and geology has a given highest weight, and after that the slope and rainfall given the least weight. So comparing all the normalized weight, we can use the weighted overlay tool in the GIS software. Then after applying these parameter in the tool, and we can get the figure 2, that is showing the groundwater potential zone basically. And in this groundwater potential map, we can see that there is a zone classified by high to very low zone. The red color is showing the high zone, and if we comparison with the other with the parameters, so we can see with the geology and lineament and drainage density, the region in the northern region, that there will be a chance to get more groundwater potential zone. And if we compare with the rainfall, it will complement to each layers to get the groundwater correctly. So overall, this is the new modern technique to get the groundwater potential zone, which will help us to mitigate the water scarcity problem in the first-hand data, because in some geological reason are available in the region that there will be very less chance to get physically go there to get the geophysical survey. So this is the first-hand data to do the further further approaches to apply further approaches to get the better result to get the groundwater potential zone in this region. So thank you for this presentation.
Thank you so much for your presentation. If you have any questions for this first presentation, please write it in Q&A, and we will go through it at the end at the coffee break. So the next presenter is Paolo Colombo. He's presenting developing integrated adaptation strategies and networking for climate resilience in urban water management in Central Europe.
So, hi everyone. I'll now talk to you about what we are doing in Italy and Croatia in the context of the Maurice project. So, climate change exacerbates extreme weather events, and having a resilient system is thus a key to be able to sustain the climate change challenge. The Maurice project works on these aspects through water management and the development of adaptive solutions for groundwater preservation. The goals are to stabilize groundwater levels and reduce floods risks, and also ensure a sustainable urban water supply. The main key outcome also is the establishment of the Maurice network, which is aimed at providing mentorship in managing groundwater and other themes touched by the project. So 6 pilot areas were identified to support water resources in cities and preserve them for future generations. In these posters, you can find 2 of them. One, the first is pilot action Varaždin, which is in a basin with the coexistence of surface water and groundwater, with a focus on nitrate and micropollutants analysis, which are spread around the area. The partners are connecting the dots between groundwater quantity and quality, and now they too will be evolving in the future due to changes in research from climate change. In the second, a highly anthropized area is studied, which is the area nearby Milan in Italy. And in this case, what we are studying is the connection between the irrigation and the groundwater system. What we want to test is if we are able to use the irrigation structure and network, which is already present, to have a managed aquifer recharge kind of action and to store water into the aquifers to be used then to reduce the drought risks during spring and summer. So the project provides climate change adaptation solutions that could be adapted for public administrations and water managers in Central Europe. These 2 are just 2 examples we wanted to share with you, but also we have other 4 actions that will be developed and are being developed right now. And here you can find some bibliography about the Milan pilot action, and we can also talk later about the project itself. So thank you for this opportunity, and also, yeah, thank you.
Thank you, Paolo, so much. So if you have a question, write it down in Q&A. And the next is establishment of a monitoring system for measuring the water conditions in the Buddha Castle cave. So the authors of this abstract, please start your presentation. You have 6 minutes.
Thank you. Good afternoon, everyone. Can you hear me?
Yes, we can hear you.
Thank you. Welcome, everyone. Okay, I can see the poster. So my name is Fanny Gazda, and I am a bachelor student at the Budapest University of Technology and Economics, Faculty of Civil Engineering. The topic of my presentation is the establishment of a monitoring system for measuring the water conditions in the Buda Castle Cave. The Castle Cave consists of natural limestone formations and artificial corridor systems, and it's located underneath the Buda Castle Hill, which is one of the country's most important symbolic sites, and its landscape is part of the UNESCO World Heritage Sites. The area above the cave is of a great administrative, economical, and cultural importance, and it has several monuments and medieval buildings. In the recent decades, several cave-ins and slope failures happened in the area, which were mostly caused by water, and this makes it necessary to investigate the water conditions in the underground areas. According to the classical hydrogeological classification, there is no contiguous body of groundwater in the area. On the plateau, the water can be defined as best as crevice groundwater. Scholars at our university, the Budapest University of Technology and Economics, have been actively researching the Buda Castle Cave for the past 40 years. In the study area of the Great Labyrinth, the infiltrating water has seemingly reached an amount that has never been experienced before. And the infiltrating water also caused weathering and rockfall, mostly at the roof of the cave. So the main motivation of this research was to preserve the current conditions in the Castle Cave. As the last measurements were suspended in 2010, it was necessary to conduct a detailed investigation of water conditions in the cave. Our aim was to develop and operate a monitoring system to assess the quantitative changes in the cave waters, as this is a key element in ensuring the rock stability. Therefore, our monitoring system consists of well water level and drip water intensity measurements. The water levels are measured in 3 wells by Datagba sensors based on head pressure with a temporal resolution of 10 minutes. This is significantly more frequent than the past measurements, which were done daily or weekly. Drip water is measured with a tipping bucket gauge that was produced and adapted to the cave conditions. Additionally, we also conducted ad hoc measurements, which were carried out at 12 locations to determine the spatial variety of the drip waters. Moving on to the results, the data series recorded for one of the wells is shown on the third figure. Also, the historical data can also be seen here. It can be seen that the average water level has decreased since the 1970s. The shape of the recovery curve is very similar to the measurements in 2009 and 10, but the recovery time has significantly increased. The short-term fluctuation in 2 wells was also detectable for the first time thanks to the high temporal resolution. Moving on to table 1, the result of the ad hoc deep water measurements can be seen here, numbered 1 to 12, compared with past measurements. The ad hoc measurements had very varying drip water intensities ranging from 30 to 6,000 milliliters per hour per square meter. It can be stated that the drip water intensities have increased since the 1970s. Based on these results, we arrived at the following conclusions: that the water levels in the wells has not risen, either stagnated or decreased since the past measurements, in contrast to the drip water intensities, which has increased since the past. Considering the cave's stability, the drip waters are more important, but this was contradictory to our original hypothesis because we assumed that the well water levels would move together with the drip waters and increase. This could mean that the wells are not necessarily made up of water infiltrating directly from the surface. So the behavior of the water levels in the wells could better be understood by numerical modeling, which I plan to develop in the future. And also a correlation analysis between the precipitation and the measured data series is also planned for my future research. So that's all, and thank you for your attention and the opportunity to present my work.
Thank you so much for this great presentation. So we are moving to Ana Vilches and Damon Montero, hydrogeochemical and groundwater quality map of Margarita Island, Venezuela. The floor is yours.
Thanks. Good afternoon for all. You can hear me?
Yes.
Okay. This work is about the geochemical and groundwater quality map of Margarita Island, Venezuela. Is a collaboration between Central University of Venezuela and a USOL consulting company. In Margarita Island, Venezuela, there is a growing demand of groundwater for residential and agro-industrial supply. However, there was not a hydrogeochemical map or a chemical water quality map that integrate the information collected over last decade. Therefore, the objective of this research was to create the geochemical and groundwater quality map. For this study, a database was created using information for the National Water Well Inventory of Environment Ministry, Meteorological Institute, and Water Ministry. This consisted in 167 samples from 142 sampling points. The methodology include statistical analysis, hydrogeochemical characterization of the samples, and the classification according Decree 883 about water quality. Finally, the map was created. For the study were sampled 5 hydrochemical phases predominate in Margarita Island. The magnesium bicarbonate phases account for 44.3% of the total samples, followed by magnesium chloride, sodium bicarbonate, and sodium sulfate. Additionally, the relative abundance of the marrow ions is as follows: magnesium, sodium, and calcium for cations, and chlorine, bicarbonate, sulfate for anions. The processes identified include the weathering of ferromagnesium silicanes and aluminum silicanes, dissolution of carbonate and sulfate mineral, oxidation of sulfides, leaching of evaporated salt in the soils, salinizations, processes from mixing food with brackish wedge, especially in Pedro González basins and La Fuente Paraguachi basins, potential mixing with the thermal water in the Santa Ana basins, and anthropogenic interventions. The chemical quality of the groundwater in the study area, according to Decree 883, correspond to class 4 in the 93.4% of the samples. This indicates a high concentration of certain species in groundwater that might be harmful for humans, animals, plants, and soils. The control of the chemical quality waters is mainly exerted by the concentration of magnesium ions. Additionally, nitrate levels impacted by agricultural and human activities across the island, exerted by the World Health Organization safe limit in at 7.5% of the sample. In conclusion, the hydrogeochemical groundwater quality of Margarita Island include data from 167 samples distributed in 9 basins, representing 5 hydrogeochemical phases. The quality corresponds principally of class 4 or acceptable according to Decree 883, and is important result that the improving the water quality will be require a specific and costly treatment system. Thanks for your attention.
Thank you so much for this presentation. Now I will let Paolo. And Paolo, the floor is yours.
Sure. So the next presentation will be impacts of interannual rainfall variability on groundwater in a micro watershed on the Amazon rainforest. So please, Alderland Brito, Savio Ferreira, and Didier Gassmans, please, the floor is yours. One.
My name is Adelina, and now I'm in Federal University of Amazonas, and now I will explain for you about my research impacts of interannual rainfall variability on groundwater in a micro watershed on Amazon rainforest. The focus of our study was identified two impacts of internal rainfall variability on shallow groundwater in a pristine micro-scale catchment in Central Amazonia, and observe the hydrological alterations in the hydrological cycle. And we used parameters like precipitation, groundwater levels, and we choose 7 piezometers distributed along a hydrological transect, covering 3 zones: lowland, plateau, slope, and our data were collected for the period of 2001 and 2021. In Figure 1, and it's possible to observe the location of our study area in the north of Brazil, specifically in Manaus City, an important commercial city, economical city in north of Brazil. In north of urban region of the city, we have micro catchment, Igarapé-Açu. In B, it's possible to observe the distribution of the piezometers along a transect in this microcatchment. In urban zone of Manaus, it's possible to observe 3 wells that we choose to compare the data that we catch of this watershed, micro watershed. In our result, and we apply in the methodology the man-candle non-parametric test for analyze precipitation, evapotranspiration, and groundwater level, and cross-correlation functions to observe the relation between precipitation and groundwater. In our results, observe tendency for increase in precipitation, evapotranspiration. In the water table is the same. The tendency of increase in preserved area in the micro watershed and in urban zones in the city of Manaus. In cross-correlation, we observe the differences in answer between groundwater table and groundwater level and precipitation. In lowland zones, piezometers react quickly one day to precipitation. In contrast, the plateau piezometers like 2 months in answer to precipitation. This difference in part are because we have different distribution along the profile in section in the watershed. In plateau, the piezometers are more deeply, and in lowlands we have more short piezometers, more shallow. And our conclusions were attendance for increase in different parameters of hydrological cycle. And it was our answers for this research, and I'm here for any question, and thank you.
Thank you. And so for the next speaker, we will have reflections on groundwater governance in Brazil from William Gotten. So please, the floor is yours.
Hello. First of all, I would like to say that my last presentation in English was 9 years ago. Please forgive me my broken English. For today's presentation, I prepared a small script. My name is William Goetting, and I am part of the research group on the governance at the Federal University of Santa Catarina, Florianópolis, Brazil. This presentation is based on my master's thesis, and where I analyzed groundwater governance within the area of covered by the Guarani Aquifer system. Thank you for the opportunity to share some of my findings with you today. My research aimed to evaluate how groundwater governance operates in Guarani Aquifer system. This aquifer is the one on the largest transboundary system in the world, shared by several countries, including Brazil. I analyzed governance structures, policies, and the practice to understand how they impact water research management. In Brazil, groundwater is vital, as 54% of cities depend only for water. The country is large reserves, but managing this are complex due to difference in regional demand and research. A strong connection between science, government, and society is needed to address these challenges. Society plays a key role in governance by demanding effective policies and take part in the decision-making. Collaboration between government, scientists, and citizens ensure balance to use preservation of groundwater. Finally, to sum up, groundwater governance is not just about government action. It's a shared responsibility between science, policy, and society. By working together, we can ensure that these research remain available for future generation. One more time, I'm sorry, my English. Thank you for listening.
Thank you. And next speaker will be about potential anti-salt microdam engineering solutions for freshwater distribution in the DAC of Itato, Kedoku. So please, Mohamed Yara Boussodiouf, the floor is yours. So, or Daniel Yamuka. I think no one is here. So we will move to the next speaker, which is about evaluation of the water response of agriculture and natural vegetation areas to groundwater droughts in central Chile, from Yongel Duran or any other of the presenters. So Francisco Zambrano, Abel Herrera, Ian Rodriguez, or Rebecca Martinez. Or anyone here from you? Please, the floor is yours. It seems even this presentation is not, the presenters are not here, so this was the last presentation of the session. So we now move to the questions. If any one of you have questions, so let's see. Will you lead these?
Yes, of course. So we
Great.
have a few questions. For the first questions are for the Artis Kumar. So is it case study or new approach for GWPM using AHM in AgroG's groundwater potential mapping presenter for you?
Yes, there is a new techniques also be there for AHM for delineating groundwater potential zones. I am using QGIS, but there will be a multi software where you can use the different models. Like I am using the MCDM, multi criteria decision making model, but you can use TOPSIS. There is a alternate model, and you can also use in different software or different model. If you want, the different languages, programming language, you can build your own model for correlating or pairwise matrix data. You can do it. There is a possibilities. Thank you.
Okay, thank you. And I have two questions for you. First one is, do you know the cover deposit height at your study area? So did you take it into account, or the cover deposits wasn't included?
I couldn't understand what about the cover deposits, but like
Did you take into account the cover deposits height, the width of that?
yeah, actually the ground like field survey has not been done yet in my study area from my side. So all these data is basically cover the only remote sensing and GIS technique, and I'm using that statistical model that is called AHP only.
Okay, thank you. And did you use something for cover analysis, like land cover analysis?
No, not yet.
Okay.
Thank
Okay,
you.
so maybe this is something that you can upgrade.
Yeah. Thank you. Yeah, that will be used. I will use future. Thank you.
Thank you so much. So the next question is about the delineation of groundwater potential zones. I think that this is the question for the Buddha Castle Caves for Fanny. So it seems to me that there are two major largest zones delineated, mostly high and moderate potential. This would mean that the study area is pretty good in terms of groundwater potential. Are there well data or borehole data currently available that could further validate those results? And how is the groundwater currently used in that area?
Yeah. Thank you. First of all, I am telling you, like if there will be a groundwater truthing has been done in the study area, that will be giving the research in the next level. But in my part, I have not done yet the ground field validation. So there is a government agency is there which is controlling all the borewell data. Like they have all the data, borewell data. There there is a groundwater control board in the India. So I will be cross correlate my all the result in the in coming days. Then that will be giving a better correlation on better validation of my remote sensing and GIS data. So that will be doing in the future. In coming days, I will do.
Okay, thank you so much. But this was the question for Miss Fanny Gazda for the Buddha Castle Cave.
Thank you so much for that question.
So please, Miss Fanny Gazda, can you answer these two questions if it's not a problem?
Yes, thank you for the question. So I'm trying to read again, sorry.
Are there any data from boreholes or wells that are available that can validate your results? And how is the groundwater currently used in that area?
The groundwater is currently not used in the area. And we also plan to do water quality measurements to assess how these are. And we have already started them, but there is not enough data, but we can state that that the concentrations are over the drinking water standards, so they are probably not usable for drinking water. And yes, there are, as far as we know, there are no other well data. And also there are not many boreholes data. Only a very few information is available about the geology of the area in the Great Labyrinth. But from the whole hill, so from the Buddha Castle hill, there are some boreholes, but they are mostly historical, so they are not very recent. But there are some, but not very detailed.
Okay, thank you so much. And I have one question. You mentioned that you will see the effect of precipitation on the data. In which way will you look at it? On the quantity or the quality of the water?
Mostly we would like to do a quantitative correlation because there is a meteorological station quite close that has already been proven that it can be used for that area. So we would like to correlate the two of them.
Great. And you can look up, because you have the quality data, you mentioned that the concentrations are higher, you can look the precipitation effect on it. So it will be really, really interesting to see it.
Yes, thank you for the suggestion.
Thank you. So do we have any more questions? You can turn on your camera and ask it. If not, I have one more question for Anna Velchet. You did the mapping of the hydrogeochemical and groundwater quality, but did you think of putting the sources of anthropogenic pollutions on the map, and just to give the higher risk maybe on that area where you stated that there are some problem regarding groundwater quality because of the hydrogeology?
Please, can you repeat? I don't understand all the question.
Sorry. So did you think about just putting on a map and the sources of the anthropogenic pollutions like industry, urban areas, or something like that, and just to see how it will affect on the area where you already have the poor quality of the groundwater due to hydrogeochemistry?
Oh, okay. The activities, or the principal activity that contaminate the groundwater is the agriculture, is the livestock. Principally by nitrate and desalinization, but evaporation of salt in the soils. This has a impact in the public zone, in zone with a high concentration of populations. But the classifications of the water according to decree is control basically for magnesium ion. In this, the anthropogenic sources don't have any impact, really. But this is important. Is equal important the nitrate and the magnesium in this case, respect the health of the humans, plants, and the soil.
Okay, thank you so much. Paolo, you have right hand.
Yeah, so I have Two questions for William Gutten. So, the first one is, so you found, like, around in your case study in Brazil, did you also consider pumping wells? Because, like, I had some experience in Brazil's, and they say there is a lot of pumping wells which are not monitored, and they extract a lot of water. So, did you consider this in your study? And the second question is, I saw that you're also part of the groundwater use network, and I wanted to ask you if you were interested in participating in the working group in groundwater governance, because you presented something about the groundwater governance. We are also considering Brazil, so maybe your input would be really really important. So these are the two questions for you.
Thank you, Paulo, for the second question. Yes, I interesting. And about the first question, the Brazil is a large country. We have a big difference and between regions. And in my state, Santa Catarina, the wells is monitoring, but in some states we don't have fiscalization or monitoring of the wells. And I to use this information for my research.
Thank you.
There are any more questions for our young professional, young authors of these beautiful presentations? You really did a great job. If not, I will ask you to share Maurice's video. So Paulo presented today our abstract, but we would like to show you some video of our project that we think is really important. Sorry, we can't hear it.
Sorry?
We can't hear the audio of the video, the sound. Still, it can be here. The sound can be here.